So hello everyone, nice to see so many of you here. My name is Paulius, I will be your moderator today. Thank you from the whole SoliTek team. I am really delighted to see so many faces here that came to our 7th organized annual conference by the whole SoliTek team. Unfortunately, for the past 2 years, of course, it didn't happen due to the reasons we all know. But now we're all here, and I would like some round of applause from each and every of you. So the topics today that our presenter is going to present will be around where the photovoltaic is heading, around agri solutions, and about energy storage solutions. Some of the presentations will be given by SoliTek team members, but most of them, of course, will be given by the guest speakers. All of the agenda you can find on the back of your badges, so take your time to look who's coming, who's going to present. I will ask all of you to mute your cell phones for the obvious reasons. If you will have any important calls to take, feel free to go to the hallway and, of course, answer it. If you will have any questions for our speakers, please ask them after the presentations will be given. So without any further ado, I would like to introduce Chairman of the Board, BOD Group, Zygimantas Vaiciunas, to the screen. He will be online from Italy.
Good morning. Good morning, colleagues. Thank you, Paulius. Thank you, Paulius. Good morning to everyone. Very nice to see so many our colleagues and friends to participate physically in Vilnius. And of course, good morning to everyone who is joining us online. Very nice to see you here. Unfortunately, in the last few years during the COVID situation, it was not so many possibilities to talk, to stay together and to discuss about the topics which are coming from the market, from the SoliTek itself, and of course from the whole world. A lot of changes was during these few years because the COVID situation, working online, of course, creates a lot of troubles for our businesses in Europe, in Lithuania, over the world. But there is some positive things as well, because we know now how to use our time in digital way, in digital time. And of course, I'm very happy that now we can reach much more bigger audience during our presentations. Short overview, 24 years for the Global Board Group as a mother company of the SoliTek, 13 years for SoliTek. Of course, during these 13 years, we have the very long journey together with you through the all things. And of course, now to see the 10, 11 years ago, sometimes we are really funny to see these pictures with our first meetings, which we done more than 10 years ago. And now SoliTek, it's one of the leader in Northern Europe to produce with a local production of the very nice products. And of course, we're expanding our range. All of these things my colleague will talk about, will explain you. And now is our warmest greetings from Italy. Italy, it's a very important country for us as well. And later on, I think Julius and colleagues will explain this why. Once more, congratulations and have a nice, successful meetings today. And if you have some questions, maybe sometimes it will be difficult to understand, to catch what we want to say. But it's a new page of SoliTek. We're not just the simple model producers, but we're, in general, we're integrators for the infrastructure. And this kind of part will be one of the biggest in the next 10, 20 years, when the European Union and all the world will move to the climate neutral economy. Once more, all the best, have a nice things, and now very short version in Lithuania. Brangus kolegos, labai malonu jūs visus matyti, visą SoliTek kolektyvą. Iš tikrųjų, praėjo 13 metų kartu, kai mes kūrėme visą šitą dalyką ir į ką mes užaugome. Tai yra naujas žingsnis, naujas etapas mums visiems, pradedant su energijos pasaugojimu, ne tik gaminimu, bet ateityje ir perdirbimu ir visą žiedinę ekonomikos struktūrą. Didžiuliai pokyčiai, džiaugiuosi už jūs visus. Sveikinu jūs visus ir didžiuojamės su visais. Taigi gero kelio, gero partneriško susitikimo, gero išdėstymo labai smulkiai ir detaliai, ką mes norime pasakyti savo produktais ir kur yra mūsų ateitis. Taigi linkėjimai iš šiltos, bet apsiniaukusios Italijos. Va tik taip po mano žodžių ir išlindo saulė. Taigi, geros dienos visiems. Have a nice journey.
Thank you for Zygimantas. So the next speaker will be the CEO of SoliTek, Julius Sakalauskas, who will present the future of SoliTek and what lies ahead for us.
Good morning, everyone. Really nice to meet you here. Welcome to Lithuania, who are here first time. Nice to see faces already familiar, met before. Thank you for dividing your time, being here and coming to SoliTek to visit us and to see what we are doing here for already 13 years with the SoliTek. And as Zygimantas told, already more than 24 years as a company group. My presentation will be mostly oriented about future of us, where we are heading to, what we will do next in the next few years. The technology is running very fast in the solar industry, so for us it's always very important to keep up with the market, with the technology, and to invest into the future. Okay, so very briefly, just a few slides who are here for the first time to introduce our company, who we are. This is a family-based company, and we are working more than 24 years in the technology business. Everything was started since 1998 with CD and DVD manufacturing, which was the first such kind of manufacturing in Baltic states. In 2009, SoliTek was born when we started to dig deeper into solar technologies, and in 2013 opened this factory which started to produce the solar cells here. This was also first such factory in the region. And in 2014, another business of ours, BOD Lenses, our sister company, who are producing eye lenses. So these three directions might look very different, but all of them are connected from the technical point of view. We are specialists on thin coatings and layers. So in all these three businesses, we have the positions of thin coatings and layers. So this led us through similar technology to the solar industry. And the next things where we are heading to will be presented here. SoliTek has grown from one company to many companies already. We have SoliTek Group inside of our group of companies already. From the mother company SoliTek Industries, we have divided companies. SoliTek R&D, this is our direction and team working in R&D projects. My colleague Julius later will hold the presentation as well to explain more where we are heading now with our research team. SoliTek Cells is a main production company of PV panels. Development is a projects developer. Here in Lithuania, we are building our own parks, big parks of solar. So this is a project developing company. SoliTek Lithuania is an installation company here in Lithuania. We have already 10 teams of installation who are doing installation both for private users and for commercial users. So this company helps us inside of our group to understand the end client, what he really needs and what he really wants. So it's like internal our customer. SoliTek Energy is our new direction of energy storage system, and SoliTek Revive is first time I am presenting this company. It's a really newborn in our group. This company will focus on energy storage and PV panels recycling business, where we are heading in few years. So it's already starting. As told before, we work closely on R&D. Since 2009, we started with the R&D. We did not start from production, but we started from the R&D, and we have team collected from that time who is still present in our team, who are working with most famous universities. You will hear their representatives today here as well. So we are proud to be with the leading companies in the industry on the technology basis. First part of the presentation, I will introduce our roadmap for the PV panels, where we are heading to and what products we will represent. And another part of presentation will be based on energy storage. So with the PV panels, our roadmap, everything here, as you know, changing very fast. Each year we need to present new type of panels, introduce higher power panels, so everything is running. So we also going ahead with the market, increasing our capacity, investing into new equipment, and introducing new modules. So step by step. So now we are installing additional equipment in current production base to increase our capacity for next year from 180 megawatts to 250 megawatts. This is the first step of increasement. In Q1 2023, we are increasing power of our Blackstar panel from current 370 watts to 400 watts. It's changing to M10 cells and half-cut technology. With the frameless panel, next year, middle of next year, we are staying with the M6 cells, full cells. Later I'll explain you why. But the idea is to move to TOPCon technology with that panel and to reach up to 390 watts. Blackstar will come as well in the middle of next year with TOPCon cells to increase the power to 400 watts, 425. And the biggest step will be a new factory where we are heading to now. 600 megawatt capacity, additional factory. So in total, we will have over 800 megawatt capacity for 2024. So we feel strong demand from the market, from our customers who are growing not in percents but in times. So all through last years we were growing in times, so we are also planning to grow in times. So 600 megawatt factory is coming online and end of next year. The place of it is still not finally decided, but we have a few options, and then the decision will come very soon, and then you will have the news updated very soon. Our main markets so far where we are working in is, of course, Scandinavia, where we started our first cooperations. We are already very active in Germany, Swiss, in Austria, Italy, Netherlands, and some new markets where we are heading to with UL certification to US market for next year. And of course, two main important markets, Italy and France for us, where we see biggest potential with Agri PV throughout next years. What is important and what we always, let's say, introduce to our customers is the way and our approach, how we produce our PV panels, what materials are used, what building we are in. This building was nominated as the greenest factory in Europe in 2013 when it was opened. We have 0 CO2 emissions in this production. Also, our, let's say, materials are selected by using these, let's say, references, and we are awarded with silver cradle-to-cradle certificate to prove let's say, all our approach to the business. This is coming more and more important in the market, and we feel the change in the market throughout recent years, that clients start paying attention how panel is produced, where it is produced, what materials are used. So we are proud to be the leaders here in this field. So our portfolio for first quarter of next year will look like this, with Blackstar 400 panel, solid bifacial frameless panel of 370, and integrated solutions like solid SolReef, solid Agro semi-transparent panel, and solid wall facade panel. A bit more about each of them. So the frameless panel, as I told before, it stays with M6 cells due to the size of it. It is, as you know, made of 3+3 millimeter glasses. It's a bit heavy for installers, and if we are going to increase it even more due to larger cells, it will be impossible to handle. So we decided to stay with the M6 full-size cells to keep the junction boxes on top of the panel, not in the middle. And with this, let's say, we can reach extreme load resistance for the panel. Latest test shows more than 10,000 pascals could be loaded on this panel. So this is why it is selling really well in snowy regions, in the Alps and in the Scandinavia. More interesting solutions what we had throughout last years. Bifacial plus tracking, this we were talking already 4 years, 5 years ago. Everybody was smiling at us, did not believe that it can generate such numbers. But we already have our own parks built in Lithuania, unfortunately in Ukraine. And we have the real numbers, how it generates. So it is really plus 40%. This is why all the market now is moving towards tracking. Because if, let's say, 3-4 years ago, you say tracking, no, it is expensive, it is nonsense, but 90% of US market now is with trackers. Another interesting solution, what we developed with German rooftop manufacturers is a white foil, which is used for, let's say, bigger buildings. It saves in a few directions. It saves you for the cooling costs, because the white layer reflects, of course, the sun. It increases your generation of bifacial panels. Test shows, which we are making even here in our factory, later factory tour you will see, generation can get higher even by 19%. And the mounting is used without the ballasts, so you can save on the construction material because it is glued to the roof, so you don't need to put the ballast. And for example, on 100 kilowatt system, it's 7.5 tons, which is really a lot. Another product which is finding its way in the market, and we see it's coming more and more, it's the facade application for new buildings and renovation. It's the facade which pays off, it's facade which generates you electricity. None other construction material will pay back for you. Okay, the payback term for PV panels on the facade is longer than on rooftop, but still it pays back. Solid SolReef, our long-term partner, Schweitzer, with whom we are doing this solution, it has really started booming for us this year. We opened some new markets, and it's really finding its customers. If you compare the price, let's say, if you put simple solar installation and roof for new house, so you overpay around 40% compared if you are putting integrated solar panels. And they are working really well. We have installations 6 years old without any problems. Schweitzer has its even more years already installed, so later Schweitzer will explain a bit more about it. Sound barriers for the railways, for the highways. This is also interesting direction where we are heading to and working, especially now in Italy, with Italian railways to put the sound barriers and to change current ones into generating power, because now they are facing really big troubles with the increased energy costs, and this is one of the solutions how we can install and use the panels twice. Another direction which is very popular, and we have another presentation here today on the Agri PV. So we also really believe in this market, as we, from the very beginning, we were producing glassless panel, a long-term panel, and this is ideal application for the agro industry, which also working in few directions, increasing your harvest and having electricity generation. Okay. Another part will be about the energy storage solutions. This is our new factory in the picture, which is built here outside the next door. You can see the construction running. We are opening it beginning of next year. It will be even more greener than this building. It will have 700 kilowatt solar installation on the rooftop and in the facade elements as well, and here we will be producing the batteries. This is the next direction where all the market, as you feel, is heading to, because without the balancing, without the energy storage, the expansion of renewables will be quite limited. So okay, so I'm not the girl with miniskirt, but I can present you our battery. So Ferrari red compatible battery. Yes, it is available in other colors as well. But yeah, this is our solution, which our team created through last years. We are also in collaboration with partners, ABE from Belgium, who are developing even more projects in Belgium as well. So it's a modular system. First product is oriented to residential use. This is where we start our, let's say, energy storage business. From small steps and from small scale in the beginning to get the knowledge, to get your feedback, our clients' feedback, how we can improve and how we can move forward. So this battery will have built-in energy manager, so you will not need to have additional installer of some energy manager or something like that. So it's already built in the battery. It's based on LFP technology to secure the maximum safety, and it's created with the mind of installers to be plug and play, let's say, installation, very easy, very fast. As told, it's a modular solution, so control block and the base plate will be sold, let's say, separately, and you can add as many 5 kilowatt battery packs as you want to your system, up to 40 kilowatt hours. This battery, as it is smart already, it can save up to 30% compared to other batteries in the market. It can also work off-grid. It has arbitrage and backup power as well. The timeline, how we are entering this and how it will look like. So in Q4 we are presenting the first, let's say, deliveries in Q1. The Energy Manager app and the software is launched. Throughout next year we will have production of 100 megawatts. This is our first line. To start the production, to ramp up, to make all the improvements necessary, and end of next year beginning of 2024, we are building 1 gigawatt factory for the energy storage. So this will be in the same factory with PV panels. PV panels plus 1 gigawatt of energy storage production plus recycling. So what that energy manager app and ecosystem will do, they will have weather forecast, which will forecast your generation of PV. It will be, let's say, energy tariffs can be regulated according to different markets where you are based, either in Sweden or in Switzerland, and control your savings and cost minimization algorithm. Everything is based on, let's say, cloud-based solution, European origin. We are not using any, let's say, Asian suppliers for the software to be completely safe. And yeah, this is the euros per day you are spending with for the electricity. Without the battery, you can spend more than 12 euros. With traditional battery, you will spend up to 6 euros. And SoliTek battery, by using smart algorithm, can save you up to 46% maximum in all the, let's say, usage. Yeah, so as told before, we are starting with a small, let's say, line in the beginning of next year of 100 megawatt capacity, just to learn ourselves, as it is also a new direction for us to learn this business and to dig deep into that. Of course, we are not newcomers. This is why we are working together with the partners from Belgium who have more than 20 years already experience in battery business, so know-how is bring from their side. In the middle of next year, we will present next product more applicable for commercial use, let's say, for commercial applications. This is larger systems and easier to install in larger scale, a bit cheaper, let's say, version, because this one is oriented into residential uses. And as told before, a big expansion of batteries, because we see enormous potential in Italy, in Germany, in Western Europe. Here in the Baltics, it's coming a bit slower, but it will come as well. So this is it. Thank you very much for coming. Thank you for listening. Any questions? If now or any time during the day or the evening.
If anyone has some questions, feel free to raise your hand and I will come with a microphone.
Radovan Kopecek, ISA Constance. Thank you for this impressive presentation. Are you planning also at some stage to go into ingot wafer cell production?
So far, no, to be open. You know our history. We started from the solar cells, so we know pretty well that business. It's really money intensive and technology intensive, and with current energy prices, what we have here in the market, I do not know how it is possible to make wafers here, for example, or ingots. So actually, no, we are moving more towards the end customer. Like here in Lithuania, we have full vertical integration from production till the end customer. So we want to understand our clients better, so we are moving towards that direction, not to the up position.
Maybe if there will be some better incentives in future, like in US, what is happening in US now?
Yeah, in US we have one partner who is let's say going into ingots, wafers. They are building 3 gigawatt factory, so we are, let's say, looking how they will succeed. So we have some partnership with them in future to become more independent from the Asian side, let's say, to buy some of the more materials from US, let's say. So yeah, we will see, but you know, everything is changing very fast, and Europe's mind now is changing. Europe's politics are changing towards the solar industry. So maybe we have a lot of know-how together with you as well, so we might join some initiatives if there will be in the market to build up, let's say, because we need in Europe to produce inside Europe.
Yeah, thank you.
Anyone else? Okay, so Julius will be after, also in all the coffee breaks, lunch, dinner, evening part, so you can go to him and ask the questions direct. Thank you, Julius. And it was a very good introduction to the next guest speaker who asked the questions, Dr. Radovan Kopecek, about PV made in Europe. So, a very good introduction from Julius.
But I think, yeah. Perfect. Okay, thank you very much, and thank you also for leaving me more time for my presentation. I have, I think, double slides, like 70. Don't worry, I have many pictures as well. So my name is Kopecek. I'm in PV now since 26 years, and I know this because I spent half of my life to photovoltaics. So I'm the co-founder and director of ISC Konstanz, and I will show you some slides about that. But as we already talked about, I think it's more and more important that Europe will go into PV production, and I will show you how, because it's clear now the hunger for modules is out there, because PV is the king of energy markets, but it will not be possible actually for China to supply modules to the rest of the world. So we need local production. So the title is PV Made in EU, the returning importance of local production and emerging technologies, like what will be happening the next 10 years. I've been to the SoliTek conference in 2019, and here you can see the proof actually, what you already told, that SoliTek is one of the pioneers of many technologies. So bifacial, Agri PV, Julius was already reporting about that at that time. And after the conference, I call it workshop, but you call it conference, you already also reported that you will partnership with Valois cell and go into IBC solar cell production. So actually, let's say you are producing solar cells under this roof, but it's a different company. It's Valois cell, and they are producing IBC solar cells. So the contacts are both on the rear side. I will show you some picture later on. So it's a fairly not new technology, but not many are producing this technology so far. So Lithuania can be really proud that to have SoliTek, and I'm happy to see that you have so many companies that you are expanding also to storage, because this will also guarantee the success of photovoltaics. Because if we want to roll it out really at the 1 terawatt scale yearly production, we need storage, hydrogen, and different possibilities to actually store the energy that is being produced. So here are two examples what SoliTek is also doing. You named it. You were one of the pioneers of bifacial tracking and also to conditioning the ground, so putting some white foils underneath the modules, which increase the albedo and the total power. So 40% of additional energy yield. It's amazing, and I think it also pays off, even if you have additional costs, of course, with the tracking and the foils underneath. And what Valois is doing, I told you, IBC solar cells, and they are mostly cooperating with the solar motors to put the solar cell into the car body. So that means in future we will not have only electric cars, but also self-charging cars. And the idea here is if you have like the entire hood equipped with a very effective IBC solar cell. So if you leave the car outside, you can charge 30 kilometers a day. So if you are using it only in the city, there is no more charging in future of the car, which is quite interesting. Of course, it's a little bit more expensive, but it pays off in future. Good, so 2022 is a perfect year for photovoltaic. As I told you, the hunger is there. Since 2020, PV became with the PERC technology the king of energy markets, and in March this year we installed a total capacity of 1 terawatt, and the plans are huge. So Europe wants to install this year 60 gigawatt, which is about 2 to 3 times more than last year. You know the reasons. We want to get independent of energy import. So Germany has big goals to install 20 gigawatt yearly, which is amazing. And the question is actually who will install that, because we don't have the manpower, we don't have the qualified people. So we have to train where to install. So double use of land, this will be very important, like Agri PV, where you can use the land 2 times. And the main question for me is also, where do the modules come from? And as I told you, local production will be extremely important for that. And US wants to install 70 gigawatt, China 80 gigawatt. So this year, people are expecting that 250 gigawatt will be installed. And but still, this is the beginning of the PV story, because if you learn from the past, what happened in the past, and this figure was made by PV magazine from the data of Bloomberg. So it's quite easy to see that every 3rd year the PV production is doubling. And this happened from 2080 already on. So if we learn from the past, and I think we will even accelerate now, that means that in 2028 we will enter a yearly 1 terawatt market. That means the capacities these days are at about 300 gigawatt yearly, so we have to triple this, and that means that there will be room for new investments and new factories out there. So US now has some good policies to really accelerate the PV production again. And I think we will hear from Zygimantas what will happen in Europe, and hopefully we will be successful as well. Yes, so the content, ISC constants, I will show you 5 slides, then some arguments about PV in EU, and also show you the most important players in Europe, then about PV technology, and at the end I will show you just some example for bifacial PV. So ISC constants, we are founded in 2005. This were the golden time of photovoltaics, where we cooperated with Solar World, Bosch, like there were many producers. And when everything went to China, ISC Constants was there involved then in technology transfer. So transferring our technology that we developed with Bosch, for example, the N-type technology, to India, China, but now also to Valois-cell. And we are focused on solar cells, module and energy systems, but do not have different companies, but departments. So we are involved in technology transfer of PERC technology. This is the main technology now that SoliTek is producing, TOPCon and IBC solar cell concept. Yes, these are our references. So we started technology transfer after Bosch stepped out in 2015. So we bought our common patents and transferred one technology to Megacell. It was an Italian company, then to India. Yes, undisclosed Asian customer. It was REC. Then SBIC is our biggest customer at the moment. And as I told you, Valoisel. Here under this roof, they are producing IBC solar cells. What will happen in future? So we are cooperating now with RCT. That's also a company in Konstanz that is actually doing the whole factory planning, and we are supplying the technology. We have now a contract with Insola, so we will transfer our IBC process to Mauritius. It's a nice place to go. So we will have no problem with our technicians to go there and do the technology transfer. Then Avada, it's a company in India. In India, there are many things happening now. Carbon, maybe you heard about it, that's a big French consortium. They now want to go into production, and not only 1 giga or 5 giga, but 20 gigawatt. They have big plans. Yeah, let's see what will happen there. So here's still the old number, 5 gigawatt TOPCon, which the technology transfer will start end of next year. Yes, here I took the picture as an example for a modern factory. Hopefully there will be more factories like that built also in France and Germany for large gigawatt cell production. So not only batteries but cells. Yes, why? We should install more capacities in Europe. You can see it actually in this graph that after a dip in the last 10 years, so unfortunately we lost 10 years, not only in Germany but in Europe because of bad policies. But now things are back on track again. So last year in Europe there were 26 gigawatt installed. As I told you, now for this year the plans is to go to 60 gigawatt, and that's why we have to increase the production in Europe. So China just cannot produce cells and modules for all the countries anymore. And I think that the big EPCs and companies that want to install modules are already feeling it, that there is a lack of modules out there, and it will be even worse in future. So here you see in 2020 the capacities of the entire value chain. So let's say on the module side, I think it's already 8 gigawatt. So we have 8 gigawatt module production in Europe, which is okay. But of course, we have to import many modules if we want to install 60. But on cell side, ingot wafer side, there are really low capacities, and mainly solar cell side. And this is my mission now with the European Solar Manufacturing Council and Zygimantas in lead for the politics to bring photovoltaic back to Europe. And but Europe is quite slow with their policies. I mean, in US now, President Biden signed a contract for subsidizing production in US. This is unfortunately not possible in Europe. But I'm quite optimistic that we will also make some good decisions. So here you see the new initiatives in 2021. What happened? There were many announcements out there. So for example, Meyer Burger was announcing to go to production, and they actually succeeded. So here in green you can see which projects were successful or which projects are online. REC, they have big plans to go into heterojunction production in France. Greenland Gigafab unfortunately is now on hold. Energetica was insolvent, but I think they are restarting. And there are also some tandem activities. Oxford PV is planning to go into tandem production. I will tell you later on what this technology is about. But as I told you, Valoisel, with under the roof of SoliTek, are also producing cells, IBC cells, and Energira, that's a company from the Netherlands, is also producing IBC modules out there. The new players, for example, I think you heard the news that NL is now going to gigawatt production. As I told you, REC, Carbon now are making advertisement for 20 gigawatt, and they really mean it, and they go vertical integrated, like starting from ingot to modules, because if you start a solar cell production only, maybe that you will not get the wafers, because if you want to be really independent, you have to produce vertical integrated, like all the products, and it's not only about wafers, but it's also about polysilicon, about glass, and this is what we are now starting in Europe, actually, that to build a big consortium also to go into production, similar to the Airbus that we did like with France and Germany a couple of years ago. And there is also a company in Turkey, Kalion PV, that increases their capacity now to 2 gigawatts. So they are producing already 1 gigawatt vertical integrated PERC from ingot to modules, and now they are moving, similar to SoliTek now, also to N-type technology, to TOPCon. Yes, I think I can skip these slides. Zygimantas will tell you more about it, what is necessary in Europe, what kind of measures do we have to take in order to bring PV production back to Europe. And yes, I can skip this one. We have now a big European project with many partners, mainly also machine builders from Germany, Rena, Centrotherm, to develop a new version of the IBC solar cell. We call it IBC for EU, and we are quite sure that actually this technology can be a strong argument to bring PV production back to Europe again. And about the PV IPSAI, which we are now doing, I think Zygimantas will report more about that. So, but in very general, PV IPSAI is an important project of common European interest. And if Europe agrees that photovoltaic production is important technology, which they already did, and countries, for example, like Lithuania is very committed, Spain, and we are now in the process to submit proposals also for the new technologies that will be produced in Europe, and then Europe will be in future able to subsidize PV production. Like the countries where the commitment comes from, they will be able somehow to subsidize, which is not so easy possible in Europe. You will hear more info about that. Okay, and when for PV technology to be really successful, we have to do it all together. And this year in Milan, in September, there will be a world conference on photovoltaics, and for the first time, after a couple of years of PV desert, the exhibition is now fully booked. So I am very happy that we will meet there and discuss how we can really achieve to bring PV back to Europe. Okay, so these were quite political things and some information about what is happening in Europe, but now about PV technology, and I call it always entering the bifacial N-type era, because P-type, like the PERC solar cells, they come to their efficiency limits, but now it's time for N-type technology, and I will tell you why. So on this slide, you can see the fast drop for prices of PV modules. Unfortunately, from last year to this year, it was the prices after 10 years or 15 years even of constantly dropping. Now it goes up again a little bit, and this happened also already in 2005. That's mainly because of the so-called polysilicon crisis. That means at the moment the major bottleneck for PV production is pure silicon, and we will solve this, let's say, in middle of 2023, because by me I mean the PV industry will solve it, because big expansions in China of polysilicon production by the Siemens process. But maybe you heard about it. There's a big discussion now, should we buy polysilicon from China because of forced labor and things like that. So we need actually also to install more polysilicon production in Europe. And we have a big polysilicon producer, which is Wacker, but they normally use also this material for electronic industry. So we have to convince Wacker to scale up their polysilicon production. But nevertheless, even with module prices at 30 cents per watt peak, it is possible to reach, in some regions like in the MENA states, electricity prices of 1 cent per kilowatt hour. That's simply unbelievable. And we are at the beginning of the journey, so it can be even below that, and I will show you how. So how is 1 cent per kilowatt hour possible? As I told you, PERC is the king of energy markets these days, and that's the major product of SoliTek. So if you look at the modules 10 years ago, not only, let's say, the power was smaller, but also the design was kind of different, like full cell and smaller modules. Now we have half cells and so on. So the modules are at lower cost because of higher power, more efficient front side, but also about bifaciality, because of bifaciality. And if you combine it with the lower cost of balance of system and also tracking, then 1 cent per kilowatt hour is possible. Of course, the average is not 1 cent. In Saudi Arabia, they have different financing models, so the average is about 3 to 4 cents per kilowatt hour these days. But how can we go even below that? So that means you have more kilowatt hour per kilowatt peak for the PERC module compared to the aluminum back surface field. And how can you go even below that is to go to not a different technology. It's very related to the PERC technology, but you are changing the N-type substrate and also partly the process. But let's say the PERC production sites can be upgraded. And then you have even more efficient modules. You have seen the forecast of the power. Then very important is also less degrading and with a lower temperature coefficient. That means if you are increasing the voltage of the module, then the temperature coefficient is lower. That means if the temperature is getting high during noon, or let's say in MENA states, then the power is still at the same level with higher voltages. Or let's say it's not going that low as for P-type. And the modules will be more bifacial as well. And it will be also interesting in future to do the more albedo enhanced measures that means to make the roof white, for example, or to putting some sheets on the bottom. And that means going to N-type, again, you have more kilowatt hour per kilowatt peak. And if you look at change at the switch from aluminum back surface field to PERC, that happened in the last few years. Here you can see the cross-section of a typical PERC solar cell. The efficiency in production is at 23%, but as I told you, PERC is now coming to its efficiency limits. And here you can see typical parameters of a PERC solar cells at M10. This is the wafer size. That's, I think, 180 times 180 or something similar. So what will happen in future is that we will have a similar change to N-type now. So this is the PERC, and we are now in 2022, so about 10% of the market share is N-type, but analysts believe that it will be also a fast change now to N-type, similar as for aluminum back surface field and PERC. So this is, I would say, the most important slide for you to understand. It's a technological slide that here you can see the yearly improvements of the efficiency on the PV market. And as I told you, in 2016-17, the aluminum back surface field came to its limits, mainly because of the rear side passivation. So actually every improvement is based on better quality of the passivation of the solar cells on the front and on the rear side. And so what actually mainly changes is the voltage. So for aluminum back surface field, you had voltages about 660, a little bit more. Then for PERC, you can go to 680, maybe 85 with selective emitters. But to go above 700 millivolt, you have to change to N-type and to so-called TOPCon technology or heterojunction and IBC. And there you can see also that you are not only, let's say, passivating the rear side better, but also the bifaciality is enhanced. That here you can see the open side of a PERC solar cell, and because you are using aluminum, so the bifaciality is about 0.7. And here you can go even to 0.9 or even above that. The question is, so this is what will happen, I think, in the next 10 years. And what will happen then? I'm not sure if the technology, if PV industry will go to tandem. This is quite unsure, because these days tandem technology based mostly on perovskite on top, they are not very well developed yet. Many people say that this technology is already mature, but we are organizing tandem workshops, and when I listen to the maturity of the tandems, it's not there yet. I mean, there are many record efficiencies announced above 30%, but these efficiencies are on small areas, so you have to scale up the size. You have to take care about the lifetime of the perovskite, because they are degrading quite a lot. But that's not the only thing, because, for example, also the reverse behavior is not very good. So yeah, let's see what will happen there. I very often compare it with the mobile network. So going from 3G to 6G. So 3G, as you know, is already obsolete. Nobody is using it. Some production in India use still aluminum back surface field, but that's because it's a lower cost technology, but it just doesn't pay off in future. Mostly we are running these days at 4G, but there's a switch to 5G. If 6G will come, nobody knows. So here you can see the cross-section of all technologies, PERC, TOPCon, heterojunction, and I don't want to bother you with too many details, but you have here you have the processes sequences. So these are the processing step, what you need in production. Of course, PERC process is a little bit more lean than TOPCon or heterojunction and IBC, but it's not only about efficiency, it's also about throughput. So you have to guarantee a good throughput, yield, and also module implementation. And let's say for heterojunction technology, it looks very simple, but the devil is, as always, in the detail. You have only low temperature processes, so in order to make really good modules, you need a different module technology. So we are very sure that actually the next big thing after PERC will be TOPCon, and let's say IBC is actually the holy grail that everybody want to have at the end. But at the moment, for many companies, it is just way too complicated to go straight on to IBC solar cells. So here you have the pros and cons of every technology. So the efficiencies are increasing, and as I told you, PERC is the working horse, TOPCon is the major challenger. I believe that heterojunction will stay still at the niche markets, but the interesting thing is here that they have the highest bifaciality. And this is the holy grail, actually, that after 10 years development, I believe that after 10 years, everything will run on IBC technology. Here you can see the pictures of the solar cells from the front and from the rear. The IBC cell is, of course, different from the others, so you don't have any metal on the front side, but both polarities on the rear side. Here you can see the modules. IBC technology can be also bifacial, even if there is quite a lot of metallization on the rear side. But let's say all technologies look, of course, in modules quite similar. If you look at the highest efficiency modules out there, so the highest efficiencies, of course, are N-type technologies, but for the moment they are still a little bit more costly than PERC, and that's why they are used mainly for rooftop application or for building integration. And what is happening in China, that actually the tier 1 manufacturers like Q-Cells, Jinko and Trina are moving to the TOPCon technology. And let's say new investors are maybe going into heterojunction to have, let's say, a different technology. But the biggest PERC producers are changing to TOPCon because, let's say, the TOPCon technology is very similar to PERC technology. And here you can see some forecasts about the capacity. That means in 2025, and I believe it will be more, is that N-type technologies will have a breakthrough. Future material challenges, as I told you, polysilicon. We are currently in a polysilicon crisis. Silver has to be reduced because of N-type technologies are using silver. Heterojunction has one more disadvantage, is the indium that is included there, and also glass and aluminum. If we enter a yearly 1 terawatt market, will become not a problem, but a challenge. And it has been also mentioned by SoliTek that circular economy with effective recycling will be more and more important, of course. Yes, I already told you tandem technology. There are many high efficiencies out there, even exceeding 30%, because putting another semiconductor on top of silicon, you can go above the shock liquefier limit. But the challenge is the stability and many other challenges. Nevertheless, I explain you very shortly the different arrangements of tandem technology. You can go for 2-terminal, where you have directly on the silicon the perovskite, and you have like the polarities on top and bottom. If you are using an IBC solar cell, you have a so-called 3-terminal solar cell with 3 polarities, or more or less you are putting 2 modules on top of each other, and then you have 4-terminal. I'm a big fan of 4-terminal, even if you have, let's say, 2 modules on top of each other, which sounds costly, but it's, I think, the easiest way, because you don't have to do the so-called current matching. Here you have to adapt really the 2 semiconductors towards each other, and that's extremely complicated. So putting 2 modules on top of each other makes more sense, and also you can have quite good bifaciality for this kind of arrangement. But I think it will take more than 10 years that this technology will be visible. What I mean by visible is that we have about 5% market share. Of course, there will be companies like Oxford PV with some niche applications for rooftop or for maybe car applications, but really in big scale it will take a lot of time. How much time do I have? It's 5 minutes? Ah, that's perfect. So now I show you some pictures of bifacial technology. Yes, here you can see how it works. The front side is still more important than the rear side, of course, but you have, depending on the cloud or of the albedo of the ground, quite a lot of power also coming from the rear side. And when we started to do advertisement for bifaciality, it was already in the year 2000. There were not many believers because they were selling modules without any problems. Doesn't matter if it was bifacial or not bifacial, but in 2018, then people were thinking to diversify from the other producers and going bifacial. I think the biggest company at that time that really made the difference was also Longi, a big producer that were saying that bifaciality will be the future. And in Europe, SoliTek was one of the pioneers that brought bifacial modules on the market. But from now on, I think it's quite clear that bifaciality is the winner, and not because it's a big revolution, it's just a revolutionary process. I told you the evolution of the solar cells, they become bifacial anyhow, and people are making glass modules anyhow, so it's just a logical consequence that bifaciality is gaining importance. And here you can see the bifacial cells and the forecast for from International Technology Roadmap. I think it will go even faster, but if it will go as they are forecasting, so in 2028, I told you we will have there already a 1 terawatt market, and 600 gigawatt from that will be bifacial. And of course, there are different arrangement of bifacial photovoltaics. Here you can see a monofacial cell in a monofacial module, and then you don't get any benefit from the rear side. You have even a benefit if you put a bifacial cell into a monofacial module. And if you have, let's say, still a spacing of a couple of millimeters, then the light can also penetrate into the rear side, mainly also in the morning when you have a very shallow incident. And there you can, even in the monofacial module, get benefit from the bifacial cell. But of course, most sense, it does make sense to put a bifacial cell into a bifacial module. And bifaciality started with fixed tilt, N-type. Then at a certain time, horizontal single axis tracking was out there, also implemented by SoliTek or by Enel in Chile. These were the first ones. And then the big breakthrough of bifaciality came when bifacial PERC came on the market. So the bifacial PERC made it really a big breakthrough, but now we are entering, as I told you, a bifacial N-type era. So the PERC technologies will be substituted by N-type technologies. Yes, you can see some bifacial arrangements. So bifacial tracking, we already talked about, that you can have the largest production curve if you make an integral, or if you are installing vertically. This is also quite an interesting arrangement, what we do with our partner next to in Germany. You have a quite an interesting shape of a feed-in curve, so you have quite low electricity in the afternoon, but quite a lot in the morning and in the afternoon. And you can also use the land 2 times, because the ground coverage ratio is almost close to 0. So for electromobility, it does not make sense to make bifacial modules, but somehow it does, for example, for some carports. Their bifaciality makes a lot of sense. Here you can see the IBC, bifacial IBC at ISC Konstanz, or we lately installed bifacial IBC on a roof of an electric ferry at Lake of Constance. So, of course, the ferry has to charge still, but it's an additional electricity for the ferry, and it looks quite nice. For standard rooftops, bifacial modules do not make a lot of sense, but for the balcony application, what is now more and more installed in Europe, it makes sense to install bifacial modules because you can have like reflection also from the wall. You can also go for flat rooftop application, then bifaciality also makes a lot of sense. If you, for example, also condition the roof, you can paint the wall white, or you can even do tracking on flat roof. Of course, you have to have a quite stable rooftop. Then this is what I told you before. This is an example of vertical installation on a roof, or some building integration. This is a building in Milan with our Bison technology. Then floating PV is coming. Unfortunately, water is not a good reflector, but still you can have, let's say, 3 or 4% additional gain on floating PV. And agricultural PV, you will hear more of that, more about it in next talks. You can go vertically, or you can go above the crops or the trees. Yes, you already talked about it, that N-type bifacial is not only for buildings. Now it's more and more penetrating into the utility scale market, and Jollywood, for example, now installed a large 700 megawatt system in Oman based on TOPCon technology, and as you can see here, I think they are copying SoliTek. So Chinese are also copying Lithuanian technology, that they are putting white reflectors below the modules. So my last slide, more or less, when I come to conclusion, is that my dream is to have in future modules, N-type modules of 23% efficiency at a very low temperature coefficient, bifacial factor quite high, and lower degradation. And the modules, I think they do not have to be too costly. It's not necessary to see modules in future for 10 cents per watt peak. We can stay at 20 cents and improve the properties of the modules, and still you will get an advantage, and you can go below 1 cent per kilowatt hour in large utility scale systems. So the 4 takeaways for today, not 3, but 4. So more modules will be needed in future as current production allows. So actually local production is extremely important. Bifacial PERC at the moment is the king of energy markets, and we will see more 1 cent per kilowatt announcements out there, of course, mainly from the MENA states. The average is at 3 to 4 cents per kilowatt hour. Bifacial NPV will be the new emperor, and SoliTek is prepared for that. So TOPCon heterojunction will be used, and IBC is then, let's say, the winner. And tandem technology is still will need about 10 years or even more to come into the market. So there we need some upscaling and stability. Issues have to be solved, and also reverse behavior and similar. So thank you very much, and I would like to invite you to the World Conference in Milano. As I told you, the fair is fully booked, so come and discuss with us how we can start PV production in Europe. Then, if you are interested, come to our bifacial workshop to Ankara, also to look at the vertical integration of PV factory and back contact workshop we are organizing this year in Constance. Thank you.
Thank you, Dr. Radovan. Anyone has any questions? Be shy, you can all ask. Okay, thank you.
Thank you.
You will also stay here during the lunch, dinner, all the day. So then you can all ask. So the next guest speaker will be Dr. Noshin Omar from ABE. He will tell us why the low voltage is a good alternative, and he will also come not on the stage, but online. So now we are dealing with some technical things. Hello, do you hear us? Do you hear us, Noshin?
Yes, perfectly.
Okay, the stage is yours.
Thank you very much. Let me just share my presentation, the screen. Can you see the presentation? Good. Ladies and gentlemen, good morning from my side. My name is Noshin Omar from company Vestra Battery Energy Engineering from Belgium, a partner of SoliTek. Please accept my apologies that I am not able to be with you in Vilnius on this beautiful day, but I'm going to do all my best to give an interesting presentation regarding the following topic: stationary batteries from development to protection, with a very clear focus on stationary applications. First of all, before starting, if you look to this figure, which is representing the battery storage markets, we see worldwide that this market is expanding due to the number of reasons which are related to instability on the grid, electricity, which are getting prices which are getting very high, increase of renewables, etc. And of course, the having more autonomy from an industrial or even household perspective. So we see here a huge increase, and this increase is reflected everywhere in the world, from China to Europe and other continents. But if we look to the market much more further, we see there is some specific segmentation in the market where the global battery energy storage market is moving very fast. And particularly, we see the biggest move is still the utility markets, which is quite very obvious, followed by commercial and residential, which is not a small part at all. And then the others which are related to that. And due to the reasons that I mentioned before, due to increase of the renewable energies and having much more need for smart grid globally, and also due to the increase of the electrification which comes to that. Now, if we look to the market much further, then we see actually from the grid-connected energy storage segmentation that there is quite a lot of differentiation there. We can see when it comes to behind the meter or in front of the meter for commercial and non-commercial. So we see there still the biggest market in that regard is in front of the meter, followed by behind the meter residential and behind the meter commercial and industrial applications. That's something which we have to take that into account, and that means also it needs a specific focus in terms of design of the solutions and in terms of solutions which are cost efficient, but also which are meeting the technical performances. Now, if we look to that large-scale storage applications, I think you are familiar with that. More and more we see large containers, 20, but mostly they are 40-feet containers, above 600, 700 volts, and such type of container where you can have 2 to 4 megawatt hour installed battery energy capacity. And then it can be combined in series, or it can be parallelized to reach the requirement that is needed. So on the right side, you see another example from BYD, where actually they are expanding that for large projects and how the configuration is typically happening. But you can have it also for commercial applications for storing much more renewables, like the left one, which is coming from Belgium. And for the right one, that is in a typical modular battery system in a rack system that we use it more for data centers and even for commercial applications as such, which is typically a perfect solution for SMEs to get it installed. Now, when it comes to home storage, we see actually quite a wide range of variation there. We see typically in the middle top, the rack system still with a modular battery modules connected with inverters, of course. Below we see the Tesla, which are water cooled. On the left side, we see another one, GSL Energy, which is much more wall-mounted solutions. And on the right side, we see the modularity, which I was tackling that from that perspective, modules which are stacked above each other to reach the specific capacity combined with the inverter, which is associated to that. So here in this dedicated market, which comes to home storage and residential, the modularity is something very important, but also the design should be done in a such way which is very easy for manufacturing to keep the cost down, and also, of course, should be very safe in operation, but also in handling. And from that perspective, in that field of residential market, there are typically two approaches. Either you go to low voltage, and when we speak about low voltage, we speak typically about 48 volt or 51 volt, and everything which is below 60 volt, which is European regulated, and above 60 volt, typically we are speaking about 400 volt. That's in two examples that I took it from LG Chem. But you have also to take into account when you go from one level of voltage to another, that means also you are dealing with another type of battery cells, and your modularity approach is changing quite a lot. This battery technology is using pouch cells, as you can see here in the middle. That's an example how they typically stack that with pro and contrast, which I will come later to that. But typically, that is how the industry is dealing with that. Now, when we speak about a battery storage for stationary application in general, you have to take into account there are a number of requirements that they have to be fulfilled. First of all, that are the performances, long lifetime, typically over 10 years, good rate capabilities, power, energy, etc. But they have also to be very safe. There have been already some accident in the past with NMC batteries in general, so safety, and particularly in household application, is very key, and so on. It should be cost efficient, of course, and there are different approaches to become cost efficient, and I'm going to tackle that afterwards. And they have to be reliable and robust for the environment where they have to be used, and compatible, of course, with different inverter technologies. So the optimal battery storage is a trade-off and combination of all these factors that should be combined in a proper way. Now, in order to do that, the battery cell technology is a very key technology in that regard. So on the left side, you see typically a prismatic cells, middle cylindrical cells, and on the right side, you see the pouch cells. And there, it comes actually to the modularity and the safety. If we look to the prismatic cell, we have here a venting system where if there will be any gases, that the gases can be released. We have a similar for the cylindrical cells, but unfortunately for the pouch cells, we don't have any venting system. If there will be any gases generated due to any met failure of the cell or the BMS, whatever, what you are going to have inside your cell and a balloon effect. So the gases will be accelerated and they will be kept and they will destroy the internal structure of the battery cell. And that is actually where big problems started with the pouch cells, and that is a solution which we are trying to avoid as much possible in this industry. So the most preferred solutions either are cylindrical cells or prismatic cells, but cylindrical cells typically have a lower lifetime, 1,000 to 2,000 cycles, and prismatic cells, they have a longer lifetime, which can go up to 8,000 cycles. Now, when we speak about that, we speak about lithium-ion technology as such, and when we speak about lithium-ion technology, we speak actually combination of materials on the cathode and the anode side. So here I summarize for you all the characteristics of lithium-ion batteries that we have on the market. That is lithium cobalt, which we typically use in our cell phones. That's maybe not so important. That's what Tesla is using, NCA, nickel, cobalt, aluminum as a cathode. NMC, which is LG is using nickel, manganese, cobalt. You see there, typically cobalt and nickel are popping up, and that are quite very expensive materials. LMO, lithium manganese oxide, where there is no cobalt, there is no nickel. And the most popular one is actually lithium iron phosphate. Lithium iron phosphate is widely used, and it has a good trade-off between good life cycle performances, power, energy, but also is quite very attractive in terms of cost. Here, lithium titanate, I think we not handle that for applications, utilities, which needs quite high power performances, and silicon graphite, that is actually to replace the graphite in the anode as such. So the most technologies, the key technology that is now used for all stationary applications due to the reason that I mentioned is lithium iron phosphate, and that's also what we are working together with the colleagues of SoliTek. Now, some type of industry, also the modularity is very important. And modularity means a solution which can be easily be extended in terms of voltage or capacity, and a modular approach without having too much modifications. And that's an example here. You see a rack system composed of modules, which can be 5, 10, or 15, or 20 kilowatt hour, and you connect them in series to reach higher voltage or capacity to reach higher and to parallel them in parallel to reach higher capacity. And then you start actually dimensioning your battery system for different needs and different types of application, which can be air-cooled, but more and more, I should say, for large container batteries, we go even to liquid cooling, and particularly some areas in south of Europe and even the Middle East, the air cooling is not fulfilling the requirements anymore. And that means the design of such type of technology is very important. Design, not only for manufacturing, but design also from a cost point of view. This is an example where you see number of cells connected in series, and where there is bus bars to connect them in series, and there are some housing around that and so on. So the design to do that is going to affect quite a lot the cost and also the performances of the battery in an appropriate way. But of course, when we speak about and the manufacturability, we speak about a battery module, you have also to understand there are also electrical components which are should be considered like fuses, contactors, which are making and the BMS battery management system, which are typically a part of a such type of a battery module at the site. This is an example how modularity can be cost efficient. Here you have a stackable and a module which doesn't require any wiring, simply where you can stack that in parallel to a specific capacity. Of course, the voltage will be then fixed for that specific scenario, which is in this case 51 volt. But actually, from handling and from integration point of view, is from end user is quite is very easy. It's just installing and placing them on each other without having too much cutting of cables or mechanical intervention, and that is making the TCO quite very interesting and also safer. But of course, to achieve an higher safety, which is a main concern of this industry, there are numbers of another aspects that should be considered. The modularity is definitely one thing, but also more and more we are making the battery system much more compact, much more solid, much more safer by integration of materials. But also the production is key element in that regard. We see a lot of batteries which are still handmade, where the mechanical connection between the battery cells are made actually by screws, and that's not the way how to do that. So they're more advanced manufacturing technologies based on laser welding, ultrasonic welding is very key. But also the monitoring of the battery cells and the modules and the pack in real environment on daily basis is a very key aspect that can be done by monitoring the state functions like state of health, state of charge of such type of batteries properly through cloud connected solutions or real time to see how they're behaving, and if there will be any troubleshooting that you can take them away. And advanced thermal management, of course, is very important because we want to keep the battery in a proper way. So typically artificial intelligence solutions, as I mentioned, which are related to cloud, is the future that has to be tackling that accordingly. Now, thermal management is very important. We know that most of the home storage or even industrial applications are still air-cooled, I would say, either passive or active. But in order to keep the best performance for lithium-ion batteries, either NMC, NCA, LFP, the temperature window should be in the range of 15 to 35 degrees. If we go above 35 degrees, we will be bringing the electrolyte inside the cell in an unstable situation where we can create actually gases, and that's what I have been demonstrated by the pouch cell. So, and the lifetime will go down. And if you go often below 0 degrees, you will be destroying your battery due to lithium plating, or if you go close to 0 degrees, your performances will go down. So it's very important to keep that. So the way where the battery will be installed and the conditions of that are very key, and it's going to decide a lot about the warranty which are related to that. And that's an example that I want to give, which gives actually the impact of the temperature over the lifetime of the battery. If you keep it in the window where the battery has been developed for, in that regard, you get the best performance. That's an example for cylindrical cells. But if you go down to very extreme low temperatures without heating, whatever, then you will destroy your battery very fast. And the same actually when it will be often at higher temperatures. So ideally, you have to stay here. If you have an operating window which is changing very fast, then heating definitely here will be needed, and cooling will be definitely there needed. So it's dependent on scenario and the conditions where you are operating. But having a good lifetime, good safety, good stability, we need also to bring the cells, the battery cells, in equal conditions in general. So that is actually the desired solution that we want to have. All battery cells are equal, and they can give the best performances. But if you will have scenario where there is huge imbalance between the cells and the battery memory is not able to handle that, then actually we are asking for problems. And that is typically where it's happening. And I can say many problems that occurred so far, explosions with home storage batteries, that were actually relating to the cell balancing failures, or the cell balancing current was not sufficient enough. In that regard, BMS is very important. BMS which is cost efficient, BMS which is modular, scalable. Scalable in series, scalable also in parallel is very important, and that is what we call typically a master-slave combination, which can be easily adapted to different scenarios, or for low voltage, or for high voltage, or for parallelized solutions. So take into account the heart of the system as for us human beings, the heart of battery system is a BMS, and BMS has to monitor that from the thermal point of view, from the energy point of view, from safety, state function, everything. It's regulating everything in a proper way. And that means there are some requirements. That means that BMS should be possible to be used for 80-volt systems, low voltage, but also should be able to be expandable to 800 volt for large-scale applications in a modular way, where the design should be done in the beginning with the possibilities to be connected in series, in parallel, with monitoring solutions through clouds, as I mentioned before. So that is actually the duty of BMS that is to be done in a proper way. And that means by doing that, you will be able to estimate the conditions, the operating condition of the battery much more accurately, precisely, to avoid any specific problem that potentially could happen. And that's a high accuracy is really needed, and that can be done also by data-driven models that can be integrated in such type of BMS to predict, estimate, and also to monitor the battery behavior in a proper way, which can be sent through a cloud to host office to check the details and the behaviors in order to avoid any problems or troubleshootings. Nevertheless, design should be done properly. That is also matching the production processes in a cost-efficient way. So the cost efficiency is typically defined by a proper design, and the proper design should be matching the production process to do that in a cost-efficient way. I have seen different product designs which were very good, but from manufacturability they were quite very difficult to do. So take that into account. The manufacturability and the design go hand in hand, and of course, as I mentioned, advanced manufacturing solutions should be integrated, like laser welding or ultrasonic welding, or even inspections, how the welding happened, etc. That all should be done in a proper way. Otherwise, problems and the quality will come above. Safety should be monitored. Why? Because we are dealing with lithium-ion technology. Lithium-ion technology, they have good characteristics, but they have also some bad characteristics. Let to be very clear. If we stay in the window of, let's say, up to 40, 50 degrees maximum, then everything is fine. But if we go above 70, 80 degrees, that is typically where problems are. And the problems start typically around 100 degrees, when there will be some failure mechanisms, that your mechanisms and system inside the battery cell will start creating problems. Electrolyte will not be stable. The binders will not become stable anymore. And then you will get a shut-off of different mechanisms over the time, and you will see the temperature will just increase. And then this temperature will increase in chain reaction mechanism, and when it will reach 1,100 degrees, then you get typically an explosion, and a very aggressive explosion, where a lot of gases also will be coming out. So please take into account where you install the batteries, either in residential or in commercial or even industrial. Be careful that should be also good ventilation and good sensoring for measuring some number of gases, which I highlighted them for you in red. But nevertheless, in Europe, we are going to have a new rule, which we call a battery passport. And this battery passport is going to monitor all the details from where the battery has been produced, based on which type of energy, was it green or not, which location, which type of materials has been used, and to the ends. Here I just took an example of the process, how it's going to happen, and where it's going to be mandatory from European Commission starting from 2025, 2026 to get that. Why? Because in Europe, we don't want that battery will be imported, which have been produced in non-green way in order to secure our market. So take that into account. There will be a lot of restrictions of imported batteries to support the local industry, which are going in the sustainability and which have also social responsibility. For that, Europe has identified a number of targets. So please take into account, in Europe, there is also a rule which says, if you produce batteries above 20 kilograms, then you are automatically also responsible for recycling. So this responsibility is very key, and those recycling efficiencies are going to be enhanced over the time. Now we are at 55%. 55% of the input material should be recycled. By 2025, we are moving to 65%, and by 2030 to 70%, which means that in the past, where only nickel and cobalt were recycled, is not going to be enough. We have now to recycle lithium, copper, aluminum, and other materials as well, because such materials should be used again as an input material for new battery types. There is another aspect that should be considered. When recycling should be done also in human way and responsible way. And on the left side, you see typically where in some area, I don't say everywhere, where some area recycling is happening. That's not the way where we want to have it. That's not the human way, not the healthy way, not respectful way. And also recycling, doing that close to houses, close to schools, close to play gardens, that's also not responsible. I just took this example from cattle in China, where big disasters happened when there was an explosion in one of their recycling plants. It was an environmental disaster to tackle that. So please take into account a design or implementation of battery, just more than just implementing that, is in a full aspect which is behind that should be respected as such. So as a conclusion, strategies toward cost efficiency, modularity of battery design is very important in the cell selection, because the cell selection is going to define the modularity constraints. Modularity, battery systems based on 48 or 51 volt is right now for home storage residential are making the best chance for safety reasons and cost reasons. BMS is going to be a key aspect in that regard, in terms to enhance the safety lifetime, but also to have these modularity functionalities. And we see a trend. In the past, we had much more battery modules of 2.5 kilowatt hour. More and more, we go to 5 and 10 kilowatt hour for the reason, because for every module, if we will be using a BMS, that is going to increase the cost quite a lot. And of course, last but not least, for a battery, you need also an inverter, and this inverter should be compatible with the BMS. So it's different approaches that should be tackled in that regards, and which are going to decide in which way it can be produced cost efficient or not. I want to thank you for your attention, and again, please accept my apologies that I couldn't be with you. And if there will be any questions, I will be glad answering to them. Thank you very much.
A question from me. Anyone has some questions? No? Everyone understood everything? So thank you, Dr. Noshin. Here is your contacts if someone needs or will want to ask question directly. You can write it down, take a picture, and of course ask. Thank you.
Thank you. Have a nice day. Bye-bye.
And I will still ask for your attention because we have one more guest speaker before the break. This is Miguel Cangas from PV Case, who will talk about agrivoltaics.
Hello, everyone. Good morning. I know that I'm the final obstacle between all of you and lunch, so I'll try to be as brief as possible, although I think we are within time, so it's all good. I'm here to talk to you about Agri PV, and thank you very much to SoliTek for inviting me to speak about this at a really timely moment, because it was just when we as a company were starting to be interested in this segment of the PV industry, which fits very well with my previous responsibilities as coordinator of the Agri-Solar workstream in Solar Power Europe. So today I'm going to basically be talking to you about what I used to do before and what I'm doing now in PV Case. So basically the plan for me today is first to give you a quick overview of what PV Case is, for those of you who don't know, and then give you a state of play of agrivoltaics in the European Union today. There are a lot of interesting things happening. And then move on to tell you about the work that I coordinated back in Solar Power Europe and with our best practice guidelines, before explaining how PV Case and our offering fits into all of this. So PV Case. I think it's particularly interesting to be here today in Lithuania and to experience firsthand an example of leadership in the solar sector from a Lithuanian company. So PV Case is also from Lithuania, headquartered in Kaunas, although we also now have offices in Vilnius. And we're basically software developers working towards being an end-to-end platform for the lifetime of solar projects. And basically we apply technology agile methods of software development to accelerate the development of solar projects with the overall objective to accelerate the fight against climate change. And really what we do is we focus very much on automation and increasing the ease of the design process of solar PV projects without sacrificing anything in the accuracy. So we really give and empower the engineers who are developing and designing projects to take and make all the decisions they need to take as easily and as accurately as possible. Our two of our products are AutoCAD based, so they work within that environment. And one of our new products, PV Case Yield, is a web-based tool that I will explain a little bit later. And I mean, I think I've just started working for PV Case less than 6 months ago. But the company, which is only 4 years old, had a phenomenal growth, really tracking the huge increase and acceleration in the solar sector. And already we have clients in 60 countries and employees in 8 countries, which is great to be part of. So, agrivoltaics in the EU. I mean, I think just before going into it, I was just reflecting about this yesterday evening, how much it has changed in the past two years. I mean, when I was first asked to work on this 2.5 years ago, there was very little, at least in the mainstream, about agrivoltaics. There was a lot of of academic literature on it, but really, you know, no one knew about agrivoltaics outside maybe some expert circles, even within the solar industry. Last night I was watching a YouTube video done by the Deutsche Welle with a lot of electronic music and really cool editing, basically giving a lot of really up-to-date and accurate information on agrivoltaics today. And I think, you know, it's really a testament to all the work that has been done that we are now there. Before going into agrivoltaics proper, I mean, I think the key imperative and the reason why we're talking about this today is because we have a huge challenge in front of us. I mean, if we want to meet our 2030 targets, we have to install at least 710 gigawatts by 2030. This year, as far as I knew before going on holiday a month and a half ago, we were on track to install 40 gigawatts in Europe. Radovan, you were saying 60. Go. I thought you were, that was, okay. So this year, then that's reassuring. I thought I was very out of tune. This year we're on track to install 40 gigawatts, which is already a huge increase from what we installed, the 26 gigawatts that we installed last year. But it's not going to be enough, and indeed, I think we have to aim much higher. And this opens a really important question, which Radovan already asked, is where these all this capacity is going to be located. Luckily, we have a lot of available land in the EU, and the solar technology is actually quite efficient in the way that it uses land, and particularly if you start thinking about dual uses. And I think this is quite important for it to be known, is that right now, today, about 40% of the land in the EU is used for agricultural purposes. The majority of that is arable land, so 56% of the total agricultural land is used for other things that are not forest, mainly. And then, if we only use 1% of that arable land, we would already far exceed what we need to install by 2030. Really, I mean, I think it's not really a land use conflict problem per se. It's just about how we prioritize and how we ensure that there are no problems about how we prioritize these land uses. And really, I mean, I think it's very interesting to see also how a growing number of EU member states are beginning to actively support agrivoltaics within their regulatory frameworks. Back when I started working on this, the only green country would have been France. And as you can see, I have had to color some countries in a darker green than France. Mainly, one of the key markets or countries in this regard is Italy, which is channeling more than 1.1 billion euros to support the development of agrivoltaic projects. I just learned this morning that we are going to see the first tenders coming out to start channeling this money, which will be based, and for me this is one of the most interesting parts, on a specific regulatory framework which includes a definition and really lays out the conditions to call something an agrivoltaic project, and also giving different tiers of support for different types of agrivoltaic projects. This is a huge advance, because before that, any agrivoltaic project that was built in the European Union was more often than not a little bit in a gray zone, to say the least. And this came with a lot of uncertainty, obviously, for the developers, and unfortunately also with a lot of bad practices, to put it some way. I think we have also very good examples of frameworks being put forward in Austria, which has supportive additional investment subsidies for agrivoltaic projects. Germany also, which held its first Agri PV solar tender, it was very undersubscribed, I think, because it was not well designed, unfortunately, but which has developed the first technical norm for voltaic projects, which is extremely useful as a first step in trying to call a cat, as we say in Belgium, trying to understand what makes actually an agrivoltaic project, and which is due to be updated and extended in the coming years, extended and updated into an actual full standard rather than a technical norm. Probably the last market I will talk about is France, which is by far the largest agrivoltaic market in Europe today, mainly because they've had since 2017 targeted support for agrivoltaic projects in the form of innovation tenders, where a lot of the innovative projects that were being supported were of an agrivoltaic nature. However, the problem in France is that the regulation is inherently unclear because it's not based on an actual law or set of laws, but rather on jurisprudence. So basically the whole set of projects were being built on two paragraphs of two court cases that lay a very short definition of what made an agrivoltaic project. What this meant was that there was a lot of, again, bad practices, which created pushback from the agricultural sector, which is the most important sector to consider when developing an agrivoltaic project. I mean, everything, and we'll go into this later, everything has to start from the farmer and the agricultural concept of the project. Another notable mention is Spain. I mean, Spain is really far behind all the other countries listed here, but they're already thinking about it. There's a possibility to get some subsidies for projects there, and they've been working for some time on a definition for agrivoltaic projects, which is, again, a really important thing. And I mean, I think the reality and the reason why it's taken so long at these regulatory frameworks is that regulating agrivoltaics is very hard. I mean, it's already not easy for solar on its own. If you bring in the agricultural side, it becomes even more complex. And it's really not straightforward because you have to bridge different sides from the mainly the agriculture and the energy policies, but then also you need to think about the environmental impacts of this dual activity and the socioeconomic context in which these projects are going to be developed, and whether or not they're going to be, for example, integrated within the rural communities where they're built. One thing that we did at Solar Power Europe when we started thinking about this is obviously as a lobbying focused organization, we started thinking, okay, what would be the most important things to tackle from a regulatory perspective, and we came with to the conclusion of these 5 main points. The first is the need to develop coherent agrivoltaic policy frameworks and legal frameworks, which should include things such as definitions or limits to the amount of ground cover ratio that would be needed to consider something agrivoltaic or not. And very much tied to that, the need, because it's not always, still not competitive, particularly with ground mount solar projects, the need to introduce specific support frameworks. And I think here notably Italy, France, and Germany and Austria is what the main thing that they're doing right is that they are providing this investment support for project developers to bridge the gap until the cost for these projects and the additional costs, which are mainly material, can be met to sell the electricity at a competitive price. But then we also have to think forward, and I think something that's really important, and which was a problem in France, and the reason why there were so many bad practices, is that there wasn't really a consistent quality assurance framework that would frame all of these projects and that would ensure that not only that the project was generating electricity correctly, but that it was also functioning as an agricultural project correctly, and that it was actually producing an agricultural output that was safe for the agricultural workers working on site. As always, in solar, and here more so, permitting is a huge issue. Because there is no regulatory framework, because there is no definitions, many permitting authorities just look at developers and raise their hand and say, "What are you talking about? I mean, you want to put agriculture here, but this is not this is industrial land if you want to build a PV project." Really, I mean, the lack of clarity slowed things down for years, and I think this is one of the most important things that is starting to change now as people start knowing about agrivoltaics, and civil servants who are part of this citizenship start to know about it. And then finally, I mean, I think because it's an inherently innovative segment of the PV industry, there needs to be a lot of public and private R&D funding channeled into agrivoltaic projects and to the agrivoltaic sector, not only to reduce costs, but particularly to better understand which types of crop and PV system design combination work best, which is something that is extremely site and geographically specific. I think still at EU level, it was really, really interesting to see that within the EU solar strategy, which I think, as we all know, had a lot of very interesting things for the solar sector in general, including good overall targets for agrivoltaics. Solar in general. This commission included two key points for me, which look minor but are very big. The first is that the European Commission has committed to publish guidance for member states to promote the development of innovative forms of solar, which include agrivoltaics. I think this is going to go a long way to open the minds of civil servants and politicians across the European Union, so that next time we speak, there are more dark green countries on that map. And particularly that they are starting to think about this from the agricultural policy side. And I think that's extremely interesting because, as I said before, the agriculture has to come first if we are going to be successful in this endeavor of agrivoltaics. And what they propose is that member states consider promoting agrivoltaics through their national strategic plans for the common agricultural policy. Now, that's what that means is, to put it in more familiar terms, the agricultural NECPs. So the long-term plans that member states have to put in place in order to explain how they're going to use the common agricultural policy funds. And already a couple of member states have included policies and measures to promote agrivoltaics. These national strategic plans are currently being reviewed and should be finalized by the end of the year. Hopefully more member states will take action in that direction. So in all that context, and actually as all of these developments were happening, within Solar Power Europe, we were trying to do a few things. First, we were trying to bring together as many players of the European agrivoltaic space, from developers to EPCs, module manufacturers, research institutes, and then trying to make sense of it all. I think there was a lot of open questions back then. There still are a lot today. But we were trying to bring everyone together and find a common European approach that could ensure that there was no divergence, notably in the, at the time, hoped for regulatory frameworks, that we didn't end up in a situation like BIPV, where you have widely different standards and technical norms governing construction products across the European Union, which really fragments the market and makes it very difficult for European players to scale up. And one of the things that we did was publish the first agri-solar best practice guidelines. We developed this collaboratively. I think there were 7 lead authors and about like 20 people in total working and editing and reviewing this document. And we did 4 main things. First, we provided a quick overview of the common barriers for agrivoltaics that existed and proposed, ways forward and how to overcome them. We introduced a framework that we called the sustainable agriculture concept, and I'll go into that later on, but whose main objective was to ensure that, as I said before, all agrivoltaic projects in the EU started from the agricultural element and side of the project. We then defined 19 best practices, both on the EPC and the O&M of agrivoltaic projects, looking at them from an agronomical, an economical, and an ecological perspective, to ensure that the impacts were either minimized or any potential benefits were maximized. And then we featured 16 case studies to illustrate all of these best practices, which include everything from open to closed agrivoltaic systems, rooftop PV on agricultural buildings, and innovative Agri PV approaches. We were also very conscious that this was a first step, and that there was probably more that we didn't know that we did know. However, I think the fact that we managed to publish this is testament that there was already a lot of things that were worth telling and that were worth pointing out. But probably in the next year or years, hopefully, we will be updating this document with the latest information, because again, as it has gone into the mainstream, we have also been learning a lot, and there have been a lot of new projects coming up online in Europe. One of the main problems with agrivoltaics or challenges, as I said before, is that it's a very complex segment. And I think I love this graph from the Fraunhofer ISA, because it really shows how quickly you get into details and the complexities in the way that you have to approach different projects. Because first you start from the top, the system can be either open or closed. That's kind of straightforward. But then you realize that you can use different structures if you were building an open agrivoltaic project. You can interspace PV, where the modules are sort of like at a normal height, or overhead, where your modules are elevated at like 2-3 meters or more. Same in closed systems. You very quickly have to divide it between the different types of buildings that are used in agriculture, mainly greenhouses and opaque buildings. And then when you go to think about the module or the module tilt or tracking systems, it starts to branch out a lot. And I think here they kept it together, but really you should have branches coming out of there again. And even with PV greenhouses, you can have tracking systems there as well. And then obviously you go down with the different agricultural applications that are possible, and you have a myriad of different systems that are possible to be developed. And because there's all of these different systems coming, finding common points that can unite all of these can be difficult. And so for a regulator or for a person like us who were trying to put forward some best practices, it's quite complex. However, I mean, I think what comes with this complexity is the need for a lot of foresight, and really an additional foresight compared to standard solar projects, because you start to have to think about these two sides, which have sometimes conflicting or very different impacts on their quality of both sides or their sustainability. And this is why we said that all agrivoltaic projects should or must start with a sustainable agriculture concept. Now, this concept, what it can take many forms, but the way we envisioned it is as a document that really defines in a lot of detail how the project is going to effectively operate both as an agricultural project and as a PV generation equipment, and lay out how these two how the criteria that are defined within the document are going to maximize the potential agrological, ecological synergies and the socioeconomic benefits to the specific location where the project is going to be located. With this sustainable agricultural concept, we saw 4 different dimensions to it: the agriculture, the environment, the socioeconomics, and the life cycle of the project. And we defined 3 main levels of importance, from a must category that should be common to all agrivoltaic projects, to a should and a could of optional and increasing levels of requirements to improve quality or sustainability. And what this allowed us is to do a first outline of all the different criteria that should be included or could be included in the sustainable agricultural concept, and the steps and actions that are that can be implemented to meet the objectives of the project. Now, I'll spare you the details. I invite you to read the guidelines, but basically what this framework allowed us to do is to come forward with a first indicative framework to assess the quality of the projects, both in 2 dimensions, in the sustainability side and in the synergies. So in the sustainability, we talked about, is the project going to be sustainable from a financial perspective, but also from a social and economic perspective in the place that it is going to be developed, but also is it respectful of the environment and of the specific location, again, that it is developed in terms of water usage or fertilizer use. In terms of synergies, we also thought that it was very important for developers and regulators to really have forward thinking about, are there any potential co-benefits that can be unlocked from developing a project that is both PV and agricultural? And what this comes out as is this 3-star system, where most of the projects built today should be are in the 1-star area. Maybe you definitely have a lot of projects that are in these 2 stars areas here. The idea that over time, with all the optional criteria becoming more widely adopted in the market, we would move towards a 3-star qualification for the majority of projects built in the European Union. Now, what we were able to do, looking at existing and high quality projects that the members of the workstream were putting forward as examples and its case studies, so we were able to outline and define 11 key areas that are very important to look at when you're doing the EPC of an agrivoltaic project. The first one of which is to start with the definition of the sustainable agriculture concept, but then include things such as ensuring the appropriate structure height for the crop being grown or the agricultural activity carried out on site, to optimize the module transparency, to ensure that there's an optimal level of light and shade reaching the crop or animals underneath, to adapt the electrical system to any potential risk from the existence of an agricultural activity on site. And what was really interesting when I started to think about this presentation is that I realized that PVKs and our suite of products really facilitates the design and the tasks required for the majority of these tasks, of these best practices, with the three ones that are not covered yet by our suite, very much focused on purely the agricultural side of any agrivoltaic project. So as I said, I mean, I think we're a very young company, and we have been thinking about agrivoltaics for very little time, I think for a couple of months. But it's very interesting because we see a lot of potential and a growing interest from our existing clients in the possibilities to use PVKs to design agrivoltaic projects. The most important element in our PVK's ground mount, which is basically an AutoCAD plugin that again facilitates all the tasks required to design and do the detailed engineering of any PV project, from the civil engineering to the electrical, including things such as ground grading or topographical analysis. And here, when we're thinking about agrivoltaic systems, the main thing that this is useful for is for open systems, both interspace and overhead, because you can design any type of system that you want, and particularly with any type of module that you need, because you're able to customize the size and shape as long as it's a rectangle of the modules used in the projects, which opens up already a lot of applications possible to be thought of in this AutoCAD environment. The next product in our suite, which is about to be launched next week, actually, is a PVK's roof mount. Here, obviously, the main application is closed systems, mainly PV greenhouses in the case of agrivoltaic projects, but if needed also for agricultural buildings. And where the focus still for the moment is on fixed systems, but where potentially in the future we'll also be able to support tracked systems. And here, I mean, you have applications such as horticulture or aquaculture that are used in closed agrivoltaic systems. And finally, the last one, which is going to be the main focus of the rest of my presentation, is PVK's Yield, which is a simulation of light software, which uses algorithms that simulate the behavior of photons as they interact with the environment that is modeled. And basically what this allows us is to design any project that we like on PVK's ground mount and then simulate its performance at a very accurate, in a very accurate way throughout the whole year. And this is also the case for systems with single-axis trackers. Now, it's not an agricultural yield software yet. For the moment, we're only thinking about it as a PV simulation software, but it already has a lot of uses that can be useful for the agrivoltaic project developers, mainly because we are able to accurately model the shading effects of the PV system on the ground. Now, we're already thinking a lot about how agrivoltaics requirements could be integrated within the software, but we're just starting. But now I just want to take you quickly through how agrivoltaic projects can be designed with our suite, which starts in the ground mount software, where you are first able to fully customize your plant design, and very easily you can both customize the module in frames and the piling distance, choosing any type of angles or single axis tracking systems. And then also in ground mount, it's very simple to select project locations and analyze and import the topography of the project site, draw its boundaries and any restrictions to auto-generate the project layout in any way you prefer. And then on PVK's ground mount, you can then add plans and generate the 3D terrain following model of your plant, and at the end you end up with something like this. Then we start working on our PVK's yield platform, where I think the first step is to upload any pan file we like. In this case, we benefited from SoliTek sending us their pan files, which made it easier for us to model. But in any way, you are able to manually define the characteristics of the module. And in the case of agrivoltaic projects, the most important parts are the cell density and the size of the module, because that's what's going to give you the shading under the module, which is going to affect the crop. But what we are able to do is very easily import the design from our CAD-based environment into our 3D simulation environment. And here you can see how the simulation looks like. You can analyze it without plants. You can see there how the sun tracks across the sky throughout the year in the system, and how the PV system generates shade that obviously changes as the days go by and as the seasons go by. And you can simulate, and we think that this is already quite useful, particularly if you're working with farmers who may have difficulty imagining what an agrivoltaic project looks like. You can already do a preliminary shading analysis and show to the farmer, look, this is how the lighting throughout the year of your crops is going to look like. Now, what we're also able to do is help developers and investors actually to find the best types of designs by enabling easy simulations of different combinations of systems. And here, for the purpose of this presentation, we simulated 4 different plans, one without plans and one with plans, with 2 different module specifications. The conventional SoliTek Vaiciunas module and the Agro PV SoliTek module to basically start thinking from an solar PV yield perspective, how different types of modules will be affecting the project. Now, obviously, one of the first things that we saw, and this is going to be extremely straightforward, is that as we increase the module transparency, there was less capacity installed on the same layout and less production. But I think this, as I said, was expected, and in a way is reassuring because it means the simulation is working. One thing that we also saw is that the presence of plants reduced the albedo on the system, and therefore decreased the generation slightly by around 3%, but still a noticeable effect. And one more thing that we found that was quite interesting is how the higher transparency of the modules increased the specific yield even in the presence of plants. So really, I mean, I think what we wanted to show you quickly with these slides is how much detail you can already see with our suite of products that will inform your decisions to develop an agrivoltaic project. So some closing comments. I think, you know, it may be that the European Union is on the boom of an agrivoltaic moment, but it's not very clear yet. I think what we need to ensure as a sector is that we do it right when we are doing agrivoltaic projects, and that we instill this foresight into project development to ensure that they are both of high quality and sustainable. And one more thing is that we, as a company, are really happy to accompany this effort by giving project developers and EPCs the tools they need to develop these projects. Now, what we are working on at the moment is on validating the PV performance predictions with operating Agri PV installations, and if anyone has any operating Agri PV installations, we'd love to get in touch. And then we're maybe more on the R&D side is already working on seeing how we can implement light availability calculations under the system, so that we can also tell the user of PVK's yield, okay, this is the exact amount of sunlight or shade which is at this specific place in the model. We want to also facilitate the addition of different plant types or different types of crops under the modules, as different plant types will have different albedos, and they will have different albedos at different times of the year. So it's also an important consideration when you are trying to think only on the PV side. And then I think this is maybe more ambitious and more longer term. We're also looking into ways where we could implement also an agricultural yield calculation tool to PVKs, to the solar PV yield, so that we would have, you know, a fully integrated agrivoltaic yield tool that's able to help developers find the best design, and also more easily convince farmers when they are working with them. I will leave it at that. I don't know if there's any questions or comments, but thanks a lot for listening.
Thank you, Miguel. Thank you for asking my question. Anyone? Oh, we have two.
Hello, thanks a lot for the presentation, very interesting. You mentioned a lot the transparency as a property of PV panels, which is important for Agri PV. Do you know, could you recommend any other thing that PV maker could focus on developing its product for the Agri PV segment, let's say? I'm asking because I'm just curious and maybe trying to collect some ideas for our R&D projects on the panel level. Yeah.
Good question. I'm not aware of other important considerations. I think really what's critical for any agrivoltaic projects is the amount and quality of light that reaches the crops under it. I think, I mean, I'm really not an expert in the field, so I don't want to say too much. But I could think about, you know, different types of glass or glass colorings could help in that sense, so that, you know, you have maybe not full transparency, but some sort of translucency, certain colors. If you would be able to capture certain wavelengths or not, that could damage the plant. I don't know. I'm not an agronomist, so I wouldn't know how to answer.
Yeah. Thanks a lot. Yeah.
Okay, thank you. Congratulations. It's really amazing what PVCase is doing. So I'm looking forward for some cleaning and watering scenarios in your system. I have actually two questions. So you mentioned you were using PAN files from SoliTek, and then I'm completely sure that they make sense. But from US, there are currently more and more news that that the systems there are underperforming. Mainly, I would say, because of, let's say, sometimes degrading modules or so-called Peter Pan files that are out there. Do you have also experience with such files that they are, let's say, very optimistic, let's say not only on the power or bifacial T level, but also on temperature coefficient? I saw already some. And my second question would be, can you already model vertical scenarios? Because I think it's not so easy, and PVCs cannot do that very precisely. But we have developed a model for it called Mobidic. So if you are interested in cooperation, then we could go for that. So first Peter Pan and then vertical.
Thanks a lot for the questions, Radovan. Yeah, no, we're very much aware of the issue with the Peter Pan files, and also the problem of underperformance of PV projects in the US, which also I think is very much related to difficulties in simulating bifacial and tracked systems combined in PV systems, and basically the whole industry working a little bit on guesstimates. Regarding the other PAN files, we are working very actively with module manufacturers or certification bodies to try and see how we can ensure that our users will get the most truthful version of the module specs when they're using our simulation software. Now it's not always easy, because not all module manufacturers nor certification bodies want to play ball, but it's something that we are very much aware and trying to mitigate. Regarding your second question, this is something that might have been implemented while I was on holiday. So I think, yes, we are able to simulate vertical plants. Definitely, I mean, I think as long as you can model it in PV's ground mount, you can simulate it. And I think that's been a little challenge with the angle of the simulation, but I think that has been fixed now, or is in the process of being fixed. Nonetheless, happy to have a conversation and collaboration. We're always looking for that, and I think that's the main reason why we're actually also attending and exhibiting at the Milan conference. So looking forward to see you there.
Thank you, Miguel. So I have some good and bad news. Bad news is I will still request your 5 minutes here, and good news, I will present none other than the Dakar legend himself, 14 times Dakar participant, Antanas Juknevičius, who will tell what is that outside.
Only a few words before your dinner. Yeah. Well, thank you very much. Just small intro. Maybe doesn't know Dakar Rally. I hope most of you know it's the harshest and most difficult rally in the world. It takes 2 weeks more, 10,000 kilometers, and it's really endurance rally. So our small private team is already 4 times Baltic state record breaker. We are 12 overall now. It's our best result. So we are now entering top 10. And this is really brilliant result for not factory teams. So we are just behind all factory teams. And why I am here? Because our partner SoliTek proposed us a solution for solar house and our assistance truck equipment. So we have 2 power plants fully installed and managed by SoliTek. And past 3 years, ISO, Mauri Sport organization that is organizing Dakar Rally, they are having a contest for, it's called Green Label. Yeah? So all team can participate in this context. And if you win it, you get a very big discount for next year because the start for this rally is around 100,000 euros. So you get 50% discount. So I'm very happy that we won this green label with the help of SoliTek. Absolutely, it was brilliant project with camper that you saw on entry. And I invite everybody in this, you will have small dinner and now you have break. So I will be there for approximately 2 hours. I expect everybody who interested to come to see the project itself and give any questions regarding this brilliant project that we, as a racers, we are still on the way to win Dakar. I know we will win it one day, but with the help of our brilliant partners here, we already won one contest in Dakar, Green Label. So we're very sustainable, a very nice project that I will tell all details there inside. So we have a nice dinner and welcome and bye.
Thank you. So, the dinner time. The dinner is. Please feel free to join in the line and have a lunch. And the break will last for 1 hour. So we'll come here at 1 o'clock. So I hope you have all had a good lunch and are eager to know more, learn more. So we had one presentation about the software for Agri PV. Now we will have more from hardware perspective about Agri PV. I welcome to stage Laura from Remtech. Thank you.
Hello everyone. So thank you for the introduction. I'm happy to be here and show you experience in Agri PV. One. There you go. Okay. So just a quick introduction on who we are, where we come from. So Remtech is an Italian and French company. It's really a leading company in Agri PV. Since we have developed our own solutions to combine agriculture and photovoltaics production. The company was founded in 2015, but the technology that we have included in the company and are developing now has its roots back in 2009 with the first patent filed worldwide, several countries around the world. So really we have more than 10 years of experience and we have plants in operation with agrivoltaic technology for more than 10 years and experience on more than 45 hectares. We are, as I said, based office in Italy and France, but we work all over the world. I know Miguel has given us a very good introduction of where we are at in the agrivoltaic market. What I want to add is that for us, for our idea, Agri PV is not only the sharing of the land between agriculture and photovoltaics, but really it's an integration of the two worlds. So we do not have adapt an existing technology for agriculture, but we started to develop the technology thinking of the agricultural needs first, and to really create a synergy between the two worlds. So to give you an overview of what we offer on the market, we have several technologies, single axis, double axis, and fixed technologies. We have started in 2009 with the first patent with the Tracker 2.1, which really was based on idea to have a low density shadow and created on the ground. With a tracker structure 5 meter high and 10 PV modules mounted on a 12-meter tracker. After the first year of operation of this technology, we have seen that shadow can actually improve the agricultural yield and can be an help for the crop. So we started to develop a new release of tracker with a higher density of panels, and we have reached now to Tracker 2.1, which is the latest release of our dual-axis tracker. The single-axis tracker uses the same structure, but only moving one axis, which can be the main axis, but also the secondary axis. I will get into deeper detail later. These structures, this tracking structure, I think are really different from what we are used to see. So we do not have all the modules close to each other, but there is a space in between to leave light to reach the crop below the plant, and to give a really dynamic shadow produced on the ground. Then recently, just last year, we have introduced in the market a new agrovoltaic family, which is a fixed system with PV modules mounted on suspended wire ropes. So the idea is to provide with a fixed solution to our clients, but also have a really large distance between the poles, which can go up to 25 meters, and a different panels distribution above the structure. So here just what we offer to our partners and clients. We can take care of design and give engineering support, but also we have internal agronomists that can provide agronomic analysis, technical support, and also maintenance and really deep R&D activity. Starting. Okay, so I thought to show you what's been in operation for these past 10 years. What's better than to see it live action. So here you see the trackers, which in this case are 4.5 meter high, are all connected to each other, and the rows of the trackers are distance. Can we maybe? So the tracker rows are placed 12-meter distance from each other, but this can be adapted to the agricultural needs. When agricultural machinery needs to work underneath the plant, the panels are placed in a flat position, so we have the entire height free for operating of the tractors. As I've said, then we have moved from that first technology to Tracker 2.1. Just to give some technical information about this, standard height of the structure and the poles is 4.5 meter, but this can be more. Let's say we arrive to 6 meter without many technical problems. The structure, the main tracker is, so this is the main axis of rotation, and it then has 4 secondary axes, which mounted a total of 24 PV modules. The PV module size is not fixed, so we can adapt the panel support based on the client requests and the PV module that it might be chosen. So there is a double rotation, as I've said before, and the trackers are mounted one next to each other and connected using wire ropes that are anchored on the soil at the perimeter. These really help with the resistance of the structure and lower the load on the foundation. So the impact on the ground is really low, and agricultural activity is not affected by this. The main thing that we manage with this kind of technology is the shadow. So the shadow is dynamic and can be controlled to reduce mainly the hydric stress on the crop underneath. So for example, with the standard tracking that maximize energy production, we have also the maximum of shadow over the crop. But there are key phases of the growth of a crop, for example, flowering, where the plant needs a full light situation. And this could be a window of 5-7 days in spring, depends on the crop. And this window really helps the growth of the plant during the entire season. So with our system, we can choose to let's say, sacrifice some part of energy production to leave full light to the plant. And this can, for example, for some cases, be the only way to agree with the farmer to have such a plant over an agricultural field. No, I'm going to back, sorry. So this is what I mean with shadow management, and this is really can be reached with the double axis system. With the single axis operation of the plant, we can find an intermediate solution, but the double axis is what gives us the most flexibility in this, and of course it is also, let's say, compensate, but they increase in production, in the energy production, of course. Then as for the fixed technology concerns, we have thought to develop a technology always based on a tensile structure. So we have these wire ropes that support the PV modules, which can be placed in different distributions. So this above is what we call the chessboard configuration, and this really reduce the impact of the shadow on the ground, because the shadow moves during the day and do not create like some rows which do not receive enough light during the day. The linear distribution is more similar to a typical PV system. And the choice between the two really depends on the agricultural needs and the impact that the shadow can have on the ground. What this solution also add to our technology portfolio is the possibility to be mounted on sloping surfaces. So while the tracker system has a limitation of 3% slope that can be tolerated, with the fixed system we can go up to 15% slope, but of course with the limitation of being like south-facing for the site. While another really advantage of the tracking solution is that we can place the row with almost any orientation, so we don't need to change the common practice of the farmer, and the farmer is more inclined to accept this kind of solution. So as I said, we have already some example. Some plants are running since more than 10 years. These are the 3 Italian plants built in 2011 with Tracker 1.0 technology. Here the ground coverage was is around 14%. this is what we have mainly increased. The total power installed with the technology is 6.7 megawatt, and we also have operation of this plant in Italy, and this really gave us an advantage in studying the operation of this kind of plant and to conduct R&D activity both on the PV side of the technology, but also on the agricultural response of the crop. As I said, we also operate around the world. After those first plants were built in Italy, there was really an obstacle in the national regulation, so the Italian market did not really develop up until the recent year, where we are starting to talk again about this technology. So we have expanded. We have gone to China, where with through a licensee we have built a 444 kilowatt plant in 2016. Then we have moved with the new technology to France in 2019, building a plant with EDF. Always with through a licensee, we have built several plants in Japan. This is one example of 834 kilowatt peak plant with the new tracker. And then we are building in this autumn with the EDF in the south of France a prototype of the new fixed technology. So let's go in deeper details about the agriculture. We have seen up until now the PV side of the technology, but we also have, as I've said, a deeper look on the agricultural side and experience. So the first evaluation that we do when defining which technology to install and develop is the impact on the shadow over the crop, and so the radiation reduction and how much the management of the shadow is needed. These are irradiation map, so it's they are calculated over a target area placed in the center of the plant that represents the behavior of the entire PV plant. So the size of the target area is defined by the distance between the row and the tracker length, or the span that we have between the poles for the fixed system. The fixed stripe agrovoltaico, as I've said, is more similar to a traditional fixed PV plant. That's where we have really static shadow on the ground, and the gradient of the irradiation is really marked. With the chessboard configuration, we managed to have a more homogeneous irradiation on the ground, so we make sure that all the points of the ground receives enough light for the growth of the crop. And the tracker, let's say, it's an intermediate solution which gives us the advantage of managing the shadow and also to have a pretty homogeneous irradiation on the ground. So also here, I wanted to show you with the video what we are doing. This is one of the 3 Italian plants where we do most of our development and research directly on field. Traditionally, in our area, cereals are the most cultivated crop. But on this plant, we've also tried to do some research over vegetables. So we have tomatoes, potatoes, pumpkin, melons, beans, and salad. And we have studied the response of this crop under different shadow configurations. So both using Tracker 1.0 Then in other areas with increased shadow using both shading nets and the prototype of the new solution 2.1, always having a control area in the full light zone to then be able to evaluate in the best way the results that we get under the field. So the research that we are doing started back in 2012 with the help of different partners. One of the main one was the University Cattolica of Piacenza, that has published a study on maize and the behavior that it has under different configuration of the agrovoltaic plant. So the simulation of the growth of the maize was done over a period of 39 years. And here we can see the red squares is the, I'm sorry, here it was changed. The red squares is the yield of the full light condition, while the gray square is and this line in particular, is the yield we get in under agrovoltaico. So even if in some years the results in full light are higher than below agrovoltaico, we can see that we have a stabilization of the crop production below agrovoltaico. This is mainly why we compensate the drought condition by reducing evapotranspiration of water from the soil. And this is really something that we are noticing now, that it's important to protect the crop from too much irradiation and let's say to reduce the stress that the heat and the sun produces on the crop. As for our internal research is giving result. These are some key parameters that we measured under the Borgo Virgilio plant in Italy. So focusing on average soil humidity, we have that with the shading, we see a higher soil humidity compared to open field condition, and this is always thanks to the shadow and the reduction of evapotranspiration. Also, the temperature is lower, of course, under the shading than in open field, and this really reduces the stress on the leaf, which can be damaged by too much sun and too intense radiation. As for crop yield and water consumption, we also got some good results. Of course, this depends on the type of crop. There are some crops that better tolerate the shadow, and some other that are more affected by that. These are to be considered preliminary results because, of course, also the crop yield is affected by different parameters, mainly related to the weather. So we need several years of research to get final results. And what we also try to do is to analyze the same crop in different climate. So with the help of our partners, we harvest the same crop in Italy, in France, in Japan, so we can compare the results. And the reason for this is, of course, to validate a software platform that can predict the crop yield in response to weather condition and to agrovoltaic plant, let's say, technology and choice of technology. To come to this graph, salads was a really good crop to analyze, and we've got last 2020 results. We got plus 23%, 32% of in the diameter of the plant, and plus 40% for last year. This year results are still in analysis, so I couldn't include them in the presentation. Water consumption is also another parameter which is affected in a good way with the presence of the plant. We reduced water consumption for tomatoes of 30% and up until 63% of water consumption reduction for pumpkins. Finally, another crop which is really interesting for the agrivoltaic sector is the grape. We have a lot of requests for plant over vineyards, and vineyards are one example of the need of the flowering phase that really needs full light in a weak period in spring. So we have measured 25% more production under agrovoltaic plant than in open field, and we have been producing for 2 years now also agrovoltaic wine for this little vineyard we have in the north of Italy, and we usually present it at the Intersolar exhibition. So if you will be there next year, we will be happy to let you try and taste our agrovoltaic wine. So this is more or less overall of what we do. Thank you.
Thank you. Thank you. Thank you. Thank you, Laura. Someday it will be turned on, but I can shout from my own. So, who's interested to know more about agrovoltaic wine or ask some other questions?
Thanks a lot, Laura, for the presentation. Can you hear me? Cool. Yeah, no, my question was about Italy, and you mentioned that things are moving now again. I was wondering if you could give us maybe a little bit more insights into what's happening and how you see, these new regulations and definitions moving the market forward. Are we going to see a gigawatt of agrivoltaic soon in Italy?
Yes, as you also mentioned before, only this year we got to the definition of guidelines to define what is agrivoltaic in Italy. Mainly they have divided by standard agrivoltaic, which also include harvesting between the rows of PV modules, so more sharing of the land that includes traditional ground-mounted system. But then they've also put emphasis on advanced agrivoltaic, which is elevated from the ground, and really also look at the monitoring of all the KPIs, not only of the PV plant, but the agricultural part. We are expecting in December new tenders for state contribution to invest in this sector. We hope something will change in the sense to give more help to innovative solution and not with traditional and already ready on the market, and so to help R&D and new development. And also another thing is that they are opening mainly to farmers or to energy company which cooperates with farmers. We hope that it will not put a limitation, because of course farmers do not have a lot of possibilities to invest directly in this kind of plant. So this would limit the power capacity of this kind of plants. But we know that there might be some changes between the consultation phase and the actual publication, so we'll see soon. And definitely the interest in this sector in Italy is escalating now.
So congratulations. It seems that EDF is going rather towards your solutions. Total has chosen, as I understood the next to sun approach rather to go vertical installed. What I like about vertical is, for example, if you install it in more northern regions, like in Germany, where we have a lot of snow, that you have like no covering of the modules. You have like really, you don't have to clean it at all. And we are working also on vertical in Atacama Desert, and then cleaning is not necessary. I guess in your regions there's not so much snow, but what about dust? Can you combine like cleaning with watering of the crops, or is the cleaning necessary, or do you have some strategies how you move the panels? Okay.
Yes, so regarding snow, first of all, it's actually easy to manage for to the tracking solution, because you just put the tracker in an inclined position, so you let the snow fall down. And also for the cleaning, we've actually seen that there is a sort of self-cleaning of the modules when it rotates, let's say in the morning, so the moisture that that forms above the modules sort of clean automatically the module. For now, the cleaning can be done from the ground by rotating the modules in the higher position with brushes from the ground. We are also looking to develop like a robot solution that can run automatically over the tracker. So this is mostly that.
Or the SoliTek modules which have self-cleaning effect can be used. So keep in mind of that. Anyone else? Okay, thank you. Thank you for your presentation. So next we have Dr. Helge, who will tell us about the futures of the roof. I know some of you are building houses, so keep a close attention. Maybe you will need SolRoof too, also. Everybody needs it, but for personal use, for the customers, for everyone.
Maybe you can hand it to the audience then after. Okay, thank you very much for inviting me here for the conference. I will talk about the SolRoof system, and I will redirect from the Agri PV to another application that also has in mind to use existing surfaces, because Agri PV is basically about using agriculture and then using it at the same time for PV. And we are talking about roofs now and using it at the same time with a sustainable attempt for PV construction. My name is Helge Hartwig. I'm working for the company of Schweizer, and the company of Schweizer is based in Switzerland. And it's a coincidence. The name of the country and the name of the family, it's a family-owned stock company, is the same, so it keeps in the mind. You can remember that. And to show a little bit around here, the idea of this so we are a supplier of mounting structure to SoliTek. They are touching the mounting structure to their modules, and the module works like a large surface roof tile afterwards. And we had a small sample here. I don't know, he's already okay, been given around. So basically you have the module and you have more or less the mounting structure here at the module. And with that you can handle it like a roof tile. So it's a very easy attempt. Let's see if it works here. So is it the arrow or forward? No, oh, this is forward, okay. Okay, so the title of my presentation is Roof Integration, the concept for modern design with manifold range of applications. So basically I want to draw your attention. That's a very easy thing, and it's a sustainable thing to use those tiles instead of tiles plus PV. And at the beginning, I will say a few words about the company of Schweitzer, because I think nowadays it's important to know whom you're dealing with. Some more details about the SOLRIF system. By the way, the name SOLRIF is Solar Roof Integration Frame, and it was invented more than 20 years ago, so we have a lot of experience with that. Then a few words about planning and installation. I won't go into the details and bother you with that. It's more the attempt and the concept that I wanted to make attractive for you. And some projects, you will find a lot of information on our website or in the internet, in Instagram and wherever. So, company of Schweitzer is now owned by Samuel Schweitzer, the 4th generation. And his statement is, the building of the future is digitally connected, energy efficient, and a solar power plant. I think this is not a secret. It's common sense at the moment, and we try to push it even harder, using any surfaces that are available for PV. And it's the 4th generation, so the company was founded in 1920, and we are not a very small company. We are 450 people in the area of Zurich, so Switzerland. And we have 3 core competencies. Yeah. So one is the building shell. So we are dealing with the building skin. We are developing facades, quoting facades, and when we get the order, then we are also producing the elements, windows and doors and everything is needed, or for other systems, adapting, and then we are mounting and also maintaining. So that's a very big business unit with doing large projects with several millions, maybe 5 projects, 10 projects a year, but with a high turnover. Then we have here a little bit strange, the letterboxes, but basically it started in 1920 with the letterboxes, and it's also a significant share. We're switching to intelligent boxes that are receiving packages from Amazon, for example, and you get a note on your mobile phone, and then you can remove the package in the evening. And then we have the PV mounting systems. Basically, the company started during the 70s with solar energy. We started producing solar energy collectors, but we are still doing that, but it's not the focus anymore, it's the PV mounting systems. And we have 2 types of mounting systems. On the left, you can see the common ones that everybody knows and everybody is using, I think, more or less, for flat roofs and pitched roofs and trapezoidal roofs and anything that helps to adjust or modules to roof. And on the right side, we have the roof integrated system. We started during the 90s with that, so we have more than 20 years experience. And the idea was really having a standard module from the market, adjusting this frame or adapting this frame, and then having high power output and everything like, benefit that you have with those modules. So the idea behind is really it replaces the classic tile. You can put it directly onto the roof, on the wooden subconstruction of the roof. It's very easy to install. You will see how it is being handled. It's reliable and high quality, especially if the module is high quality. I mean, that's the key, I think. You have a much higher yield per square meter than, for example, with those small tiles where you have 4 cells laminated onto it, or whatever. You know, there's a lot of variety in the market with different tiles working similar. It's proven over 20 years, and we have a software tool, web-based. I will have a few remarks onto that. So what you can see here on the left side is a roof with counterbattens, or a membrane counterbattens and horizontal battens prepared for the SOLRIF modules. And on the right side, you can see basically a roof being prepared with tiles, and afterwards installing modules above that. And this is not really the lean way of doing it, I think. It's much more effort, it's much more energy, and still we are used doing that, and just only because the interface is clearer. So somebody is doing the tiles, then roof is finished, and somewhere later someone comes and installs the PV. So that's very easy to us, but now we get installing PV mandatory. We get the rules that we should install with constructing or reconstructing the roofs. So it doesn't really make sense to put first tiles and then modules. Makes much more sense to put the modules directly. And yeah, the advantages is much faster installation, only once, modules directly, less gray energy, so less material, and you have less weight, by the way. And a big benefit is the superior design. It looks much nicer if you have an integrated solution on the roof. We have several additional advantages here with the solar system. For example, I will focus only on a few aspects, that the module is lying on the lath and the long side of the module is being supported by the lath, and statically that's much more, it's much better than just punctual support with clamps and things like that. Then it is basically an inlay system. So you put the clamps and you lay the module into the clamps, and then the module can move. Every module can move itself during expansion and compression or temperature raise and decrease. It can move, so there's no stress on the modules. That means you don't have any damage there. It works really fine there. And yeah, there's some figures here for the weight. If you have, for example, 15 kilogram per square meter with a glass-glass module by SoliTek, then you would have 15 plus at least 30 kilogram with a tile on the roof. So that's a big difference and might make the difference, might be important. Then there's an additional feature. We call it a 7/8 frame. So if you see a little bit closer, there's a second sample. Maybe you want to have a look and give it to the others. Oh, maybe everybody saw it already. So you have no frame on the bottom. That means you have a much better self-cleaning effect. So water, rainwater that's coming down, is washing away the dust and everything. With agriculture, maybe, yeah, if you can switch it, then dirt is also being washed down, but here with the free lower edge, you have the same effect here. Yes, and just to show how it is being installed, you have those different small clamps here. See it here? 3 different types. We have samples here as well. So module plus those clamps, that's a mounting structure. You basically don't need much more. And you need to put as much clamps as are needed in your certain circumstances statically required. So you have 1 clamp at the interlocking parts of the modules and additional clamps in the middle. And the calculation gives you the number that has to be placed. And we have this little tool here that is helping to place those clamps. Oh, so that didn't work. I don't know. To start the movie here, maybe here. No, that's a touch screen. But this is yeah, that's the movie. It doesn't work. So that's. Oh, I cannot start the clip here. So basically, the clip that is not starting now is showing that it's really easy with this tool. You just put it. I have to be careful. I don't. You put it here on top of the module, for example, and you lay down. Yeah. So it's very easy. You put the tool there, put the number of clamps that is required into the spaces of the tool, and you fix it with screws. And so you go on module by module. So the installing is simple as it can be, much easier than the on-roof installation. So I think the mounting itself is without question much easier. So from my point of view, the challenge is the coordination of those craftsmen, different craftsmen that are building a roof. So first, we have the carpenter who is doing the wooden substructure. The substructure is completely identical if you put tiles afterwards or if you put modules afterwards. That doesn't make any difference. Then you need someone who's putting the modules and connecting them electrically. And you need someone who is closing the roof or the leftovers of the roof. And you might need a tinsmith who is doing some connecting details. And you have to coordinate. It depends on the configuration. If you, for example, covering the roof completely, then the tinsmith has to come first, have to do the flashings on bottom and on left, on the right, and then you put the modules, and afterwards he has to finish on top. So that's things that might complicate that a little bit. And I think the challenge is the different craftsmen, they have to talk to each other and they have to find a solution how to easily install it. That might be a little bit more offending, but it's something that architects, for example, do always. They coordinate the people who are building the building, and then it works fine. And if you have a little bit of experience, then it's very easy to do. Our approach is now to supply standard flashings here. Basically, we are supplying to SoliTek, and SoliTek is able to provide the complete package. And there we have a standard solution to connect between the modules and the tiles. We have some top flashings, we call it ridge flashings, some interconnections, bumper flashings, and so on. And side flashings, left side and right side. And with it, you are able to put the modules onto the roof with all the flashings. Then the PV installer is off, and then the roofer comes and covers the roof with the tiles as it is always with him. So there's nothing different for him. And we extended this range here to cover a bit more of possible shapes here. On top of the roof, we added some flashings for the inner corners here. So on the right side, you can see 4 different types of inner corners. And basically, it's done by a little bit smaller side flashing and a little bit smaller ridge flashing, and then with some interconnecting parts. You can have a left corner on top and a right corner on top. And on the bottom as well, you leave away the flashing profiles, and you have a certain flashing that is connecting here in the inner corner. So the idea behind is really to provide standard solutions, put it onto the roof, and then the roofer comes afterwards, so the craftsmen know who is doing what. And if it's closed afterwards, it looks like this. And on the construction site here, it's a triangle-shaped roof, and you can, by the way, see that you can also shift rows against each other. And then you have standard solutions for those corners. And with those black tiles and with covering the remains with the black tiles, you might have a really nice homogeneous view of that. And it makes it easy to do one after the other. So the idea basically is carpenter is preparing the roof. The solateur or electrician is placing the modules. And afterwards, if there are any leftovers, then the roofer is putting a few tiles to complete the roof. And you don't need the tinsmith anymore. So I think a lot of challenges occurring here are linked to the shape, different shape of the roofs. And the mounting itself is really easy, and the planning process, that's something you have to have in mind, and where you might need a little bit of experience. But I think there's really a tendency of doing that more often. In Switzerland is a very common use to build integrated solutions, but for example in Germany it's not really common. We still try to push and to find partners and build up a network and so on. Just a few words about the software. I mean, basically it's a web-based software, state-of-the-art, and you can choose location from Google Maps, and then you have the map for the wind load and the snow load, so picking the loads very easy and so on. You might draw roofs from Google Maps, so if you know the location and it's a retrofit, for example, then you can very easily draw the roof and have a load calculation, and then you have a CID drawing that shows you. CID drawing is the next picture. You select the module here, and then you get a CID drawing afterwards. So you can choose here between several modules. Basically, it's only important to pick the correct size. And you can, for example, see when SoliTek is increasing the power from 350, 355, 360. In terms of installation, it's always the same, and it's the same frame and the same concept of putting the modules on top. So that's a real big benefit that we are benefiting from the increased power there. Yeah, and as a result, you get the CID plan of the roof here with all the important dimensions. I mean, the most important dimension is the size of the generator here, horizontally and vertically, because you might have to shift it a little bit on the roof or make sure that there's sufficient space and things like that. So you have to keep that in mind. You have also the grid dimensions here, horizontally and vertically. So you know how to place here the battens, you know how to place the modules. And one very important feature is the blue clamps here, or the blue fixing points, is at the interconnection of the modules, and the glass ones, the additional ones in the middle, that's the yellow ones, is given by the program. By the way, we have here always 2 glass clamps, so it's very easy, but that might vary, that you have at the edge of the roof only 1 or even 3, something like that. But it's scalable, very easy scalable there for different load situations. Yeah, there are some brochures. You find it on our website. I don't know, Julius, if SoliTek is also providing a branded version on your website, but there's some information. I have a few brochures with me. I will put them onto the table afterwards. The idea basically is here on the left side, the brochure for the end customer, so with nice projects, interesting him for that, and on the right side it's for the installer, where you can see all the details for the mounting and the installation of that. So a few projects here. There has been, that was the first larger project in Switzerland. On the left side in 1999 was already a large installation on multifamily houses with small Kyocera modules. So it was, I don't know, exactly 27 or something cells, small modules. And in 2018, they added a new section of those buildings, retrofitted them, and installed here much larger surfaces and much more power onto the roofs. But basically it shows that they were believing into the system and using it again 20 years after. So we have, we are going quite frequently onto construction sites and helping people to do, if they do it the first time. So we see that there's a lot of projects being realized. That's one from Berlin here with a dormer and completely covered everywhere. And working with so-called dummy modules here around the windows. So we have a silver-framed metal sheet, and you can cut that, and you can have the flashings and the interconnection, and then it looks very homogeneous and it's very easy to install because everything is standard then. Yeah, something here, retrofit. I like that because it's an antithesis here between old and new. So an old farmhouse and retrofitting the barn here. That looks really nice, and it has been completely covered as well, and also with dummy modules filled. Yeah, same thing here. Very homogeneous, dark surface. I don't know if you can see that, but also being dummy modules installed here on the bottom with a different size than the other modules, making snow that's sliding down, not shading the modules, and filling the roof, so the remaining surface here. Then something that's coming up is colored modules as well, so there's a lot of request. There's different technologies of coloring modules. Here it is ceramical printing on the glass. For sure that makes a difference, so you lose a lot of power. But sometimes in monumental protected areas, it's more important to keep the color, and it's still producing energy. So yeah, that's a trend we can see, especially if we want to cover even more buildings everywhere. You can see also glass being framed with SORIF, so you have a little bit skylight there in those sections. And you can also see here a snow barrier that's being put on so-called dummy modules. Yeah, I think basically the direction is going on to covering as much as possible. I mean, that's always depending on the technology below. And on the circumstances here and the feed-in conditions and so on, but basically we want to generate as much power as we can do. And here on the right side, for example, we have a storage as well, a hydrogen storage. And the owner said, I want to provide all my demand in electricity and also 15,000 kilometers a year with my electric car. So he put a 900 kilowatt hours hydrogen storage there. It's a little bit weird, but basically I think shows the tendency. Yeah, same thing here. Oh, movie doesn't work, sorry. So we would see different views of the roof, because basically three of those four roofs are being covered completely with a solution here. And only the north-facing roof is with metal sheet, the common metal sheet. And very special here is that they built also dummy modules here for this section of the roof, and they put cells just to make the same view, which is much effort for just a little bit of appearance or better appearance. Yeah, sorry, the movie here is also not working. You only see here a little bit remains of the roof. It's inside Stuttgart, the town hall, and underneath is the Ministry for Energy. And they put here an integrated solution onto the roof. It's 90 kilowatts, so it's a large installation. And the reason, or the argument was basically that the roof would not bear tiles with PV, so they had to replace the tiles with the PV directly, which is a good argument. Yeah, also a roof near Munich, where you can see everything that is manageable with a solution. And yeah, as you might imagine, it gets quite challenging here, because you have to solute a few details, but it is possible. And if you have good workmanship, then it's no problem, basically. So on our website, we are collecting those details just as a proposal for someone who has similar boundary conditions and wants to cover the roof completely. And we collect it here, for example, for the roof eave, when you go directly into the drainage on the bottom, you don't have tiles there, how you can handle that, or how you would do a ventilated ridge. Or here at the verge or roof valley, so we are collecting there a lot of details if someone has to find a solution there. he can check our website and get the drawings. So there's a lot of information on our website, www.solref.com, and it's arranged a little bit here for the decision maker, so the one who is deciding. And from our point of view, there's very often the customer who says, I want an integrated solution. It should look very similar to what I've seen. And then he needs a planner who's doing it for him, and an installer as well. And that's the value chain where we try to connect everybody with everybody and build up a network, especially in Germany, because we think there's a big potential there. Large market and only a very low share of integrated solutions. Okay, that's basically my statement for the roof integrated solution in cooperation with the SoliTek modules. Are there questions?
Thank you for the presentation. It was really impressive. I have a few questions regarding the water management and what is the slope of the roof. It's not so big, so it's low slopes. Usually in Cyprus we have low slopes. And what's about the water management, the leakages and so on?
Yeah, thank you for the question. I mean, basically, it's totally the same if you have tiles or if you have those modules, because we are talking about a standard roof pitch, and that has been tested. And for the system, it is 22 degrees. And that means above 22 degrees, it works really fine. And below 22 degrees, you need to have additional security. So, for example, the membrane underneath being glued and not only laid, overlapping, and so on, but then you can go down to 10 degrees. But one thing is the 22 degrees is very important, because above it's very easy, and below you have to be a little bit more careful. But the ruler's instructions, they tell you exactly how you handle that in that case. And that means if you have overflow, because with tiles you might have that as well, then it's dropping onto the membrane and then being driven out of the construction. So nothing happens to the roof, basically. So that's the concept, and you need that also for condensation, because you might have a lot of condensation on the back of the modules dripping down in the morning after being very cold in the night.
Two things. Is there any space for ventilation of the modules and to installing, let's say, the power optimizers if you're using SolarEdge? Is there any space underneath the panels for that?
The answer is very simple, yes, 2 times. No, I just wanted to go back to the picture where you can see the construction with the counter buttons and the buttons. So you at least have this ventilation space here in the region of the counter buttons and of the buttons. So in Germany it would be typical around 6 centimeters, something like that, but it's totally standard for roofs like that. And you can fix those to the LAS, the optimizers there in the space, and it's being behind the module, so protected by weather. Mm-hmm. Yeah.
Thank you very much. I have 2 questions. Normally, you can step on a tail. Can you step on a panel? And the other question is only for a string inverter or also for a microinverter?
Yeah, so basically that was the question with a microinverter. If your microinverter is fixed to the module, then you can use it as it is. And if you have an optimizer there, you can fix it somewhere in the space in between. And the other question was if you are allowed to step onto the modules. And that depends a little bit on the module. Normally, the module manufacturers, they don't want you to step there because you might get microcracks in the cells. So better not, is my answer. I know that sometimes they are doing that, or they are stepping onto the profiles at the interlocking sections if they need to get up there very rapidly, then sometimes they do, but better not, because that might be a problem then with the warranty of the modules.
Better not, but 10,500 pascals, maybe you can. Additional questions? No? So thank you, Helge. So next we have the European Solar Manufacturing Council President, Zygimantas Vaiciunas, who will say about the breakthrough of European PV manufacturing. When? Probably now. And how?
Good afternoon. First of all, of course, we really appreciate that you were able to come to Lithuania in general and to SoliTek company in particular. Lithuania is well known for the fight for the energy independence and, of course, implementing creative solutions in the energy sector. But, of course, now we are suffering, as all the Europe are suffering, from the high energy prices and especially electricity prices. So before moving further, just a couple of introductory remarks. I think that all the Europe have to admit that we were too slow and we implemented too little of the PV in the recent past years. And last but not the least, we were too little creative in some of the solutions. I had a talk with Karolis Kiguolis, the next presenter, about the demand side response on all the other issues. So now we are paying the price for this slowness and the pace which was not enough in the recent past years. So the key question is now for the future, and today we are listening for the presentations, and we see a huge potential, incredibly increasing potential for the solar PV, both for the solar parks and the integrated solutions. But the key question is where the models will come from, as Radovan was pointing out before. So in my presentation, I will look at these things in principle. And of course, here in the SoliTek company, I'm working as a VOD group member of the board. And of course, I'm the policy director of the European Solar Manufacturing Council. The organization, which is in principle created 2 years ago, we have more than 40 members already now. And the target is very clear, to have as much as possible PV production here in Europe. We have to admit that this mission is not so easy, having in mind that a lot of politicians, many of the politicians, are not willing even to open the doors for the European producers and to listen to the key problems. Now we see that to some extent the Commission is already opening the doors. We have the conversations. It seems that also some other European politicians, ministers, also listen to our problems and issues. And they do hope that the PV manufacturing landscape and the ecosystem in Europe will be very different after 2 or 3 years from now. But let's start, and in this presentation, mainly I will look from the bird view perspective. What are the potential in Europe and what is necessary to be done that for such a companies like SoliTek, we would have more such a companies, and that will be growing and moving forward to ensure the competitive European PV manufacturing. So, of course, there will be 5 key questions. Of course, the first question is where we are now. And the second one, where we are planning to go. How fast we can manufacture PV in Europe, and what could be the the critical mass of the PV manufacturing. What are the key factors for our success? And last but not the least, what is our role in this process? So, you already saw the slide. It is a little bit updated, but this was before the summer break, the data in May this year. And as you see, we have two key challenges. One challenge is that last year in Europe it was installed 26 gigawatts capacity of the PV. Later, of course, it was the updates that it was 32 because statistics are always lagging behind. And when we are looking to the numbers, we see that one challenge is that even for the PV models, we have not enough of the capacity. It is 8 gigawatts capacity. The second issue, the second problem, that along the value chain, we have the key problems, that this is just 0 point something, and this is all along the value chain. So the key question is, Quo vadis Europe? Is it the right approach to the PV manufacturing? Probably not. And that's the question which we have to answer in all the EU member states together with the right regulatory framework. So what is the consequence of that? The consequence is now everybody's paying high electricity prices. And we have the consequence that we are just flowing euros from Europe, not always euros, sometimes this is also converted into the dollars, but about 8 billion euros just loss because of our incapability to produce enough of supply for the increasing demand in Europe. And in case we are just implementing this scenario for 2030, which is Europe and the European Commission now is forecasting, this deficit, this trading deficit of DP production could increase to 15 or even 20 billion euros. So this scenario, nor one of the politicians wants, but this is the first point which we have to admit, and from that perspective to see what is necessary to be done. So all the European Commission is really pointing out nice decarbonization scenarios, nice Green Deal ambitions, of course the independence from Russian gas and so on and so on. But we have a serious problem here. And of course, now every politician in Europe is busy with the higher gas prices. But in such a conferences like this, we are really discussing the key facts, what is necessary to be done that PV manufacturing will be on the table of every politician in Europe. So here's just one of the examples while the ESMC and also Solar Power Europe was lobbying for the separate solar strategy. We succeeded to get this document finally, but the road was not so easy. Because we just talked with the Commission, I personally talked with the Commission like last year in April. The work program has been approved in November, and the strategy has been adopted in May this year. So you see how what is the pace of the Commission and the European Union. So for that we have to live, but we have to make all the efforts that this will be more supportive for the PV manufacturing. So in that strategy, of course, this is not something like going to the moon, but I'm just referring to the well-known Neil Armstrong phases, that this is like a small step for the EU energy independence, but one giant leap for the EU solar industry. Why it is so? This is so because in January this year, the Commission was forecasted 420 gigawatts capacity till 2030. Just after 1 month, and the reason is well known, after the 24th of February, the approach changed. And in the strategy now we have 600 gigawatts capacity. So it means that the capacity has been increased just because of one geopolitical reason. And now we have the capacities, which Radovan was mentioning, Miguel was mentioning. We have the capacities of the installation, yearly installation from 45 to 60 or even 70 gigawatts in the European Union. So that will be really a key challenge for us. And also I think it is the case that the lesson has been learned to be too much dependent on the supply chain and all the production which is coming from Asia. So, of course, there are more nice things in that strategy. Of course, talking about the rooftop installations, about the supporting frameworks for the Agri PV, and so on. One number is very clear that for these initiatives, at least 24 billion euros will be necessary from now till 2027. Later on, we will talk about the billions and what is the essence of that, but just wanted to show that this was the first time when the Commission systemically was looking at not only the demand part, but also the PV manufacturing part. Here it is, the slide from the McKinsey company, and now with the ESMC is working with the McKinsey, and we are planning to present the study. It will be presented after 2 weeks, as the European Union Solar PV Industry Alliance will be formed. So we will need some very concrete numbers to move forward. So you see that it's in principle that the target is really incredible in the EU solar energy strategy, 600 gigawatts. So it means that till 2025 we have to install at least 60 gigawatts per year, and from 2025 at least 70 gigawatts per year. Just to remind that last year it was 26. So how fast the manufacturing capacities in Europe could be developed? And we have to admit that now we are counting this by 1, 2, 3, 5 gigawatts capacity in Europe. And this is, of course, the critical mass and the critical parts of the value chain. So in principle, Europe is moving forward to the premium segment, as the SoliTek is doing now. And this is really one of the strategies to move forward. But without the scaling of the PV manufacturing, it will not be feasible to achieve the numbers which is mentioned in the EU solar energy strategy. So the phase 2 could be that in next year, 2023, it will be, of course, best to have at least 10 to 20 gigawatts capacity. And also that will be multiple sites and emerging ecosystem here in Europe. Phase 3 could be fully competitive European supply chain, meaning that it will be the scaling effect all across the Europe. So what will be in that study? It will be we are looking at the cost difference between the Asian production and the European production, and what are the support mechanisms which are necessary. Because it is well known that the Inflation Reduction Act, which is now working in the United States, it's one of the clear measures where it will be hard to implement in Europe due to the competitiveness conditions. But we have to admit that without additional instruments, all the PV manufacturing business will be moving to United States, because it's really quite supportive system for the PV manufacturing. What I wanted to show also the capacity of the billions, how much is necessary to have the additional support to scale up these capacities. And yesterday, the European Commission President von der Leyen, in her State of the Union speech, referred to one interesting number. This is 140 billion euros, which will be the fund to leverage the current high prices of electricity in Europe. So this will be gathered from all the wind and electricity, because this is the idea to have the ceilings of 18 euro cents per kilowatt. And that fund could be used to compensate for the industries and for the individual consumers. So we are talking about 140 billion euros just for the compensation for 1 year or 1 year and a half. And we should be able to find at least 5 billion euros for the PV manufacturing. So these numbers we will bring together, and we will be moving to the Commission to talk with the different DGs. But we have to admit one fact, that one of our key targets was quite successful, that now the European Commission will be creating this EU Solar PV Industry Alliance, which will be officially launched in November. But now the Commission is starting the work. But the key question is that now it's easier for the industry to communicate, because the machinery in the European Commission, we have very different DGs, very different levels. So even to the simple solution, you have to meet at least 20 persons in Brussels to have the decision proposed, not made, but proposed. So this solar industry industrial alliance will be really supportive for us, because we will have one window to talk with the Commission. And it will be solving a lot of issues for us, for the manufacturing industry. So this is just a question how and where the European Union invested in the recent years. And we see really large investments in the R&D. As Radovan was mentioning, really a good example that this was the first points while the PV manufacturing capacities has been created in Europe. We have green color also for the strategic autonomy and technological sovereignty in 2021, a new industrial strategy, also 2022. Also, we have large demand and specific needs for the solar installations. And here I'm referring to the same solar energy strategy, which is referring to the huge future for the solar PV industry. What we are lagging for? We are lagging for the financial capital costs and also operational costs. It means that we have to solve this issue. And the scheme is very simple. Later on, I will show the numbers, but in case there will be a possibility for the long-term and cheap money to borrow, there will be a game changer for all the PV manufacturing in Europe. And of course, the legacy of that we have not a critical mass of the PV manufacturing capacities in Europe to be enough competitive and to be in that market to compete globally. Last but not least, of course, we have moderate, polysilicon, small wafer cells and glass production. But this is also connected with the same circle, because there are no critical mass, there are no demand, no supply in Europe. So it seems that not so much should be done to change the landscape and to change the ecosystem, but it should be done as soon as possible, as fast as possible. So here are some of the factors for our success, and we have really successfully pointed out that it's a good point, a good start that the European Commission already prepared that solar strategy. It's a good point that Solar Industry Alliance will be starting the work. We would like to have this earlier, faster, but it seems that it will be starting the work right now. In September, Commission is planning to approve all the necessary procedures, and it will be the three main elements of that alliance. So one of them will be identifying manufacturing scale-up bottlenecks, and also provide recommendations not only for the Commission but also for the Member States. The second thing is facilitate access to finance, the thing which I was mentioning before, and also how to establish the commercialization pathways for the R&D production here in Europe. Last but not least, the third point, it will provide the framework for the offtake solutions between the producers and the buyers. This is one of the elements which could be simply implemented without the recreation or without changing of the EU competition rules, but this will be very important for the industry to know what is the demand, and not only to know the theoretical demand, but to have really clear contracts for 2 or 3 years and so on. And of course, there will be some more software things about the circularity, recyclability skills, and so on. The next question is, can we have the appropriate PV manufacturing capacities without clear target? Absolutely not. On that, we are striving with the Commission to have the number in this Solar Strategy Alliance, and it seems that our strategy is successful. Before, the Commission was not talking about the concrete targets for the PV manufacturing. It was the targets for the deployment, but not for the manufacturing. Now it is included that in 2025 we have to have the target for 30 gigawatts capacity. And then for 2030, we have sent the proposal that it should be between 60 and 80, at least. This should be the target for the European Union. You may be smiling that it is too big. It's it's really ambitious, but not realistic. I do expect that this will be the same smile as this was smile from the SoliTek bifacial panels like 3 years ago, and that now this is the trend. So we are expecting that these numbers will be included into the strategy and into this solar PV industry alliance terms of references, because it is strategically important. Afterwards, from the industry perspective, we can go to the Commission and to the member states to raise the number and to ask for the incentives. That's why this is very strategically important. I do hope that soon we will have these numbers included. Of course, when it will be included, it should be loudly represented by the industry, the key players which are planning to do the business, PV manufacturing business in Europe. And of course, financially supported by the financial institutions. So what are the realistic commitments that the PV manufacturing community is prepared to take over? You see the numbers in 2023, 20 gigawatts, in 2027, additional 14 gigawatts, and 2030, 26 gigawatts in addition. So to sum up, we have 60 gigawatts already prepared till 2030. You may ask from where these are the numbers. These are the numbers from our members, only from the ESMC members. We made the questionnaire with the presumption, in case there would be the possibility to borrow finance for 1% interest rates for 7 or 10 years, what will be your strategy? So this was the answer. Of course, it is the general numbers, not to the particular companies, but the message is clear. The European PV manufacturing industry is prepared to move forward, and the only issue is the cost of the capital. So what are the key deliverables for the EU PV manufacturing renaissance to be a reality? As I was referring to the financing, we are calculating that between 3 and 5 billion euros additional support will be necessary to create attractive loan system. And of course, it will be the key message and key instrument to launch the PV manufacturing in Europe as soon as possible. Of course, secure demand. This is the off-take agreements between the producers, suppliers, and the final off-takers. This instrument will be the part of the agenda of this solar PV industry alliance. And we do hope that this mechanism could be quite a creative one, but it will be really competitive for the European Union producers. And then, last but not the least, innovations for the competitiveness. This is the question that in the ESMC we have initiated the project of common European interest for the PV. This is so-called PV IPCI framework, in which we are targeting to have the support for the industry. You know the very strict rules, the competition rules in the European Union. So this is the instrument. This is, of course, not the silver bullet, because it will not solve all the challenges. But in addition, with the two mentioned before, it could really ensure the long-term competitiveness for the European PV manufacturers. And here, of course, the same slide from the PV IPCI framework. Now we have 59 members on board. We have created 6 projects already. So they are moving forward and they are developing. Before, like at the end of the last year, even the Commission was quite skeptical about this initiative. But now it's included in the EU solar strategy. And this is clearly set, black on white in the paper, in the electronic version, that the European Commission will support the member states' effort to pursue the PV IPCI for the innovative solutions. So there's the clear message to the member states we're glad to hear that now we have 6 member states on board. We are working with such members like Germany, France, Netherlands, and it seems that they are now more supportive than it was before. We do hope that they will have these members on board quite soon, and we will be able to pre-notify these projects to the European Commission. It depends on every state regulations, but there is a possibility once the pre-notification is done to start moving with the projects. And then the only question is that the preparation of the national governments to finance the projects. And afterwards, when the Commission is just clearing the state aid procedures, then this is retroactively approving these financial resources which has been done for this project. So this is not an easy way to get the support, but this is the way how we can ensure the competitiveness for the PV manufacturing industry from the long-term perspective. And here, of course, are some of the projects. You see the financial part of that. Of course, this is the preliminary calculations as the projects are moving forward and they are more concrete. So we have, in principle, only in the PV-IPCI portfolio, 35 gigawatts capacity innovative solutions. The total capex is 3.3 billion euros, and the expected support or the funding gap, this is about 1 billion euros. So this is, in principle, this is a peanuts in case we are comparing with such a packages like the leverage package which has been proposed yesterday of 140 billion euros across the European Union. So, last but not least, what is our role in that process? It's really should be a framework solution. It cannot be just one solution which could be solving all the issues or all the challenges for the industry. Of course, it is not an easy task, but worth to be taken. And here I'm mentioning some of them. That, of course, industrial actors support and to believe in this solar PV industry alliance, very concrete proposals. Sometimes maybe tough proposals, but concrete proposals that the Commission will be moving forward and also proposing this for the member states. I should say that we also have to form the PV offtake alliances. Nobody is just making obstacles for us to do that. This is feasible, but it depends on the market situation. It depends how far we are prepared to move and to take this step forward. Eco-design and energy labeling, it's always the question which is in the Commission agenda. We have to admit that after 1 year work, still the proposals will be just the next year, in March or April next year. This will be also helping the European PV manufacturing industry, but its timing, of course, is of the essence. Also together with this, I think the forced labor issue is one of the critical elements. In case we are counting European models, the models which has been sold to European market, in every second model you can find the footprint of the forced labor. And we are really congratulating the initiatives like of the European Bank for Reconstruction and Development, that they will not support the projects financially, they will not give the loans for the projects in which we implemented with the models which has been produced with the forced labor. Of course, it is a challenge to make the clear examples and so on, but it should be the strategy that the producer should make the certificates that this had been produced without the forced labor. And we do expect that other financial institutions like the European Investment Bank also will be moving to the same path, and also then the member states to follow. Of course, educated political stakeholders, the issue on which we have to take care and of course to invest our attention. I was personally surprised that politicians, ministers, vice ministers, and some middle-level people was thinking that this fight is already done, that all the PV production should be going from Asia, from China, and we have just to live with that. So this is the general approach in Europe, and we have to change that. But we can change only with your views, with your approaches, with your explanations. That's the only thing what we can do from the industry perspective. And of course, educated consumers. We have a lot of examples when we have to present that the European produced production PV models are better for them just for natural reasons. And consumers also are listening for that. This is especially in the current days when the payback period of the solar models, of the solar solutions are so fast. They are listening to this, and of course we have very good examples as a SoliTek company now. We have expansion of the solar installations all across the Lithuania, and the Lithuanian models are really treated on the right manner. And last but not the least, banding produced in EU solar PV models. This is the thing on which the PV companies, PV manufacturing companies should work shoulder to shoulder, and also to create some soft things which is not always dedicated to the financial support mechanism, but this should be like a branding that we have the European production, which is not in a worst quality situation, but it is better from the longer term perspective. So that would be like a summary of the key points, but the key message is of course that this way, long way, will not be easy, but this is the only opportunity for Europe to realize the current situation. And of course that's also the lesson which has been learned, that Europe was too slow of implementing the PV deployment. Now we cannot let us to be too slow while taking care of our PV manufacturing business. And I do hope that SoliTek will be driving this force further. In any case, I believe that SoliTek will survive because this is really a resistant company. But with such elements, we can have more capacities and we can have more European production here in Lithuania, in Central Eastern and Western Europe. So this is my wish for the future, and we do hope that this future will be coming quite soon. Thank you very much.
So the bright future lays ahead of us. Any questions?
Thank you very much, Zygimantas. So I must say I'm a big Lithuanian fan, and not only because of SoliTek, this is I told many times, but also because of Lithuanian politics. And when I was here in 2019, I was very surprised how young the politicians here are. You were the Minister for Energy, and so thank you very much for doing this. You are the right man at the right place at the moment, doing work for European Solar Manufacturing Council, and I think that we can be successful. And I'm talking to the German government. Yesterday we had some quite intensive talks also about the PV IPCEI, and they still did not understand the importance of this, but I'm sure that they will, because we have continuous talks with now Minister Habeck, who is now also the young generation. So after a couple of years of Angela Merkel, who was a good politician, but actually the problem was that there were like old people in the positions having quite good connections to the oil industry, gas industry, as we all know. And now everything is changed, and now the mindset is different. Unfortunately, as I said, it's going too slow. My question would be, you as experienced politician, what do you think would be the most important thing to accelerate? I mean, we are in a good process now, but still it's going somehow still too slow. US, they just brought very good regulation on the market, and as you said, we have to be careful now that not all the investment will be done in US now. So what do you think, how can we even accelerate? And I know you are doing a very good job, but somehow, yes, what will be answered to the, and the other question, who is in this PV manufacturing alliance? Is there a call for membership, or will that be selected by the leading people there?
Yes, thank you for the question. And yes, for the PV manufacturing, we have to be as fast as Ferrari. No, that's or Tesla in that case, yes, because this is the only issue when how we can be competitive. And speaking very practically, this is connected with the second question. The EU Solar PV Industry Alliance, this is the only channel now for us to transmit the key detailed proposals. How it will be structured, this is in principle, of course, now it's informal work is taking place, but I do see that the main associations will be on the table, meaning European Solar Manufacturing Council, meaning Solar Power Europe, and Energy probably. So that will be the core, these three organizations, as they are representing the manufacturing part of the industry. And the key issue is that like we have to propose not only the theoretical things, but also to make the analysis, what should be done and what could be the commitment from the industry side. So that's why with the McKinsey company we are doing this study to present very clear numbers and to show what are the price gaps between the Asian production and European production. I mean, not from the concrete company perspective, but on the general view. And then also to see how long these instruments could be competitive. Because you know very well also from the German perspective that the issue is that once the politicians even believe that we can be competitive, the next question is how long we can be competitive. So that's the two quick questions which we have to answer in the Solar PV Industry Alliance. And you're absolutely right that the timing is like next 6-8 months for us to take decisions on the European Union level. As I said, one of the good scenarios, one of the good points is that now we will have the body in the Commission, and the Commission will be participating in all these formations, in the steering committee of this Solar PV Industry Alliance, in the project groups and so on. So in principle, it will be one clear opinion from the Commission. Now we have, and we are struggling with that, we have different positions of the DG Energy. Once we have the support from DG Energy, DG Grow, then moving to the DG Competition, we have the support from the political level, but we have no support from the middle level. So that was all the time the was challenge for us. So I do believe that Commission also understands this very well, that to have one voice from the Commission side, it will be more productive also to agree on the key instruments, what we have to do in the forthcoming future. But as I said before, the key is facts, just to show also to compare what are the others are doing, and we have to be not more saint than the Pope, how to say that. We have to think about the creative solutions, because in case we will be always thinking about the current frameworks that it doesn't allow us to do nothing, we will be stopping at the same point. So I do believe that this Solar PV Industry Alliance will be turning the things on a different manner, and that of course will be also the cooperation between the Kadri Simpson, between Breton, and also maybe one more vice president to be included. So it means that it will be a push from also high level, and I do believe that it could be a good experience that we can be moving forward as the battery alliance has been formed. There were some lessons learned, not all the best things also there was moving, but I do think that Solar PV Industry Alliance could be more productive in that sense. So a lot of wish to this alliance, and I do expect that till the end of the year we can propose very concrete elements to the Commission, and that could be implemented as soon as possible. Thank you.
Any more?
Hi, my name is Murat. I'm from BSTG from the Netherlands. My question is, do you expect to have an MIP again in Europe?
MAP. No, I don't believe that it could be implemented quite soon, because it was the lesson learned from the past. And the issue is that, as I said, it cannot be one strong solution which could be changing the landscape. And as you saw, the capacities which should be implemented in Europe quite soon is too high that we can think or even thought about such instruments.
That's it. So now we have a coffee break. There is the coffee, there is the sweets. Feel free to have 15 minutes, and we will get back 5 minutes after 3. Thank you, Zygimantas. Are you all fresh for the last part? 3 presentations left. 3. So slowly and steadily I will invite on the stage Karolis Kiguolis from Fusebox, independent electricity aggregator representing. Everyone is ready to listen? Do we have your attention? Okay, so we start. The stage is yours.
Okay, thank you. So, thank you, Zygimantas, for the last presentation. It was very interesting to see some digits. Our company not selling solar panels, we're not selling batteries, but we're like mediator for the providers who doing this. And I think this is one of the main thing if you're talking about green energy, about renewable energy, about solar and about wind. Like I always talking with governments, with clients, it is, if you take a coin, it is 2 sides. So one side with renewable energy is growing and will grow, and it's very good because it's new future. But if you're looking from electricity balancing operator side, we have a lot of job, guys. We have a lot of job in every country and in Lithuania as well. But I see what a lot of people from different countries, from Germany, from Netherlands, from Italy. So, like, if we're talking about Germany, so I know what renewable energy is growing times. I just see from the numbers, and I can't imagine how work electricity balancing operators have. And you know, it is something like I like to talk inside market. So if you're talking about our solutions, and what I want to talk about today in the next 10-20 minutes, it's about solar, batteries, and grid. I call it demand-side response. If you're talking about Fusebox, so yesterday we are in the market already 8 years, and we are one of the most innovative startup in Europe. We are in top 100. But if you're talking about accessibility, not only for the batteries, but for the buildings like this, to participate in demand-side response, business centers, industrial companies, water utilities, and so on. Especially today, when we have one of the biggest energy crises in Europe history, all industrial companies starting change the mindset and be flexible, because if we're talking with industry companies, nobody wants to change their work because it's hard. But I will talk more about maybe special information what I will talk from the experience, because today already in Estonia and Finland we have integrated more than 3 megawatt of batteries, energy storage, and it is one inside information what if you're talking about business perspective, if I'm investor and I'm looking for, I want to build a 10-20 megawatt solar park. It is one thing what we don't need to forget. Electricity, big prices, it not will be always like this. One day we have a lot of green energy, a lot of solar, a lot of wind, and electricity price starts going down. So to avoid this, you can put in solar parks, in buildings which have solar panels, or in some other objects, the batteries. And the batteries allows you to participate in demand-side response with Fusebox virtual power plant and to get extra revenue, solid extra revenue. And if you're talking about imbalance and the digits of megawatt hours, what is, if we look for the last 3 years, just to take a Lithuanian example, what imbalance in electricity balancing operator have maybe 3 times less than we have now, because in the last 3 years the renewables energy also it starts and continues growing quite in big numbers in Lithuania as well. So it's a big opportunity. In these slides I show very fresh example from the PV storage from 2020 August. So if you take battery size 1 megawatt, so it is marketing some mistake, it is 1 and 2 megawatts. So in this position, if you see this digits in a below 1.2 million. So I will explain a little bit. So to buy a battery just for storage and just to avoid big prices in Nord Pool is not a business case. To buy battery and participate in demand side response in electricity balancing market, this is the case. We have done the calculation, but the feedback, if we invest a battery, like example, I take a price from one of our partners, Pixie, Norwegian company for battery providers. 1 megawatt battery, its prices are around 700,000 euros. So if we using this battery for demand side as well, so the feedback time, it's less than 5 years. In some of the cases, it can be less than 3 years. So, and if we took this 1 megawatt and we use between 1.5 and 2 times per day, and bring this safe electricity brings to electricity balancing market, not to Nord Pool, extra revenue in 5 years, it will be more than 1.2 megawatt. Sorry, 1.2 million euros. So I'm talking now in copper market price, so it's Lithuania, Latvia, Estonia. If we take Scandinavian balancing electricity price prices cap, it is totally bigger, And if you take like example Germany, what is imbalance is very big in a balancing market. The price cap sometimes grows till 100,000 euros per 1 mega hour of flexibility. So this is what you must know, and your future clients must know. And this is very interesting example how to avoid solar panel, solar park cannibalism. I don't like to use this word, but if you're talking about if you're talking about possibility to do business smart, so I think this is the possibility. So if you're talking if in this case we're using the batteries, and if you want to avoid low energy prices in the middle of the day, we can take the solar energy and save to the battery, and also to sell it in the Nord Pool in the evening when the price is bigger. Or you can bring it with fuse box to the electricity balancing market, which always price for 1 megawatt hour is bigger than in Nord Pool. And if you talk about market price, what I can say, it's like a golden rule, you know. Doesn't matter in which country, but electricity balancing market is the most like important market in every country, you know. It doesn't matter how much the Nord Pool price in one and another hour. If electricity balancing operator, they didn't balance the grid, so you can using the electricity. And we see today not a lot blackout, but we see some blackouts, and in United States of America and in Balkan countries. So you know, this is opportunity to talk and to use the batteries like extra aggregator, and to use it smart, and to look forward one day. Maybe it is the possibility, maybe the solar parks produce the what we get the electricity from solar, we put to the batteries, and we produce only to electricity balancing market, to the grid, not to the Nord Pool. And this is what the if you're talking about the business case, this is what you must know, and your client must know in the future as well. So the fuse box, mostly we say what we are software platform, and we are not selling batteries, and we are not selling solar panels, but we are like integrator in this big game, and we can bring really good benefits and to make grid safe and to save CO2 as well. If you're talking about Baltic states, we participating in MFFR market. Of course, in Scandinavia, we also are in another markets which are existing today. And also, I didn't maybe put some extra slides about the batteries and hydro, the batteries and business center, the batteries and you know, like in industrial big companies. But it is like if somebody asks me, you know, I will tell one sentence always. If it is sun, it is must to be batteries as well. And today, if we look very, if we focus for energy, for European Union, and about all the stuff what is going from political, okay, I don't want to talk about this because this is I don't think that we can change here. But another thing, what is a lot of subsidies coming, and like example, I just a few days ago talked with some company which doing consultants in Lithuania, and they said that like in Lithuania it's starting subsidy for the government institutions like schools, hospitals, and so on, like 3 million euros and 3 megawatt of battery. So this is a good this is a good case, and I hope maybe in the future the business and private households also they can have some subsidies. So if you're talking about integration time, when the client buys a battery, it is on only 3 weeks. So in example, if I can mention one of our partners, Pixie, it takes from the order till implementation only 8 weeks. Also, we have some testings, also what we're doing with Huawei today. So in the future, I think we have more partners, and I hope to see SoliTek as well, and maybe we talked before with Zygimantas to make a test with his batteries, and to see maybe it will be one of the first batteries in demand-side response market, which is providing Lithuanian company. So this is also unique experience what is waiting for us. If you're talking about revenue sharings, so from batteries and fuse box, it is like 85% extra revenue from balance electricity, which we provide to grid, gets the customer, and 50% take fuse box. We have all this, I can say, like platform, what you can see online. You can see all the information, and you take the last 1 year, the last 2 weeks. So this is everything is open because we building virtual power plant globally. Today we are only in 9 countries, but I hope so in the next 5 years we go to all Europe, and not only. So all technical advices and commercial, I can say, like consultations and financial consultations we do already from practice. We have today around 15, 16 objects in Estonia and Finland, which are integrated already into electricity balancing market and get revenue. So this is from my side. It's quite short, but very concrete. So if you want to ask me something, you can ask now, or you can, I can share with you my visit card, and we can have in the future to talk about some collaboration in your countries. So thank you for the time. Thank you, SoliTek, for invitation. And I hope it will be some new, fresh information about inside market, which mostly the people we don't know, and what is not, what is here, you know, because everybody know Nord Pool about energy crisis. But I just talked with Vice Minister of Energy 2 days ago, and the problem we have in Lithuania, but nobody talking about this because nobody have experience, you know. So this is a big problem, and I said, it is, we calculate with a team what in Lithuania it is without batteries. We're not calculating batteries. In Lithuania it is about 60 million euros which dropping on the floor, and nobody wants to take it because nobody, we need a lot of time to explain. And I want to say one thing, this object, we integrated now into electricity balance market, so I hope you know, the people from the company next year can say we have benefits in feedback, in CO2 savings and extra revenue, 100,000 or 200,000 euros, or maybe less, or maybe more. So let's see. Just one thing before ending. Doesn't matter how much electricity prices will rise in Nord Pool or globally. Demand side response in the next 40 years will rise more than 40 times globally, because we increasing renewables globally. So it's like solar, wind, hydrogen. Hydrogen is also green energy. So I can say this just from the another countries like Germany, New Zealand, and I just talk about a record. So the last year, the record was make with New Zealand 3 days in a row. We pay more than $230,000 for every megawatt hour of flexibility. So this guy just to think about. So thank you a lot, and if you have some question, please ask.
Any questions? Thank you. So, as you see on the back side of your badges, Dr. Virginijus Radziukynienė should tell a speech, but he is not present. So his wife, Neringa Radziukynienė, from the same Lithuanian Energy Institute, will give a presentation about Horizon 2020 project, Energy Keeper.
Okay, good afternoon, dear participants. I am Neringa Radziukynienė. I am from Lithuanian Energy Institute, and today I'm very glad to participate in this international conference. And as you see, the presentations are going to the end, and I really hope to pay your attention, that you are still having some power to listen to it. And I really hope that my presentation will be quite interesting and innovative solution. Together with me in this conference came my colleague Artūras Klementavičius, as we were coordinators of this international project. So please take time during my presentation or any time to ask any questions from me or from my colleague. So the title of today's presentation is Horizon 2020 Project Energy Keeper, Breakthrough to Sound, Flexible and Collective Energy Storage. And so, it's doubled. Okay, let's start. Actually, Lithuanian Energy Institute has had a honor to participate in a very interesting international project, Energy Keeper. It was about energy redox flow storage solution, and this project was funded by European Commission. During the period of the project, we needed to move through the three main goals: to develop a new type redox flow battery technology, integrate the battery into smart grid environment, and demonstrate battery operation in industrial relevant environment. Maybe not everybody of you know what is redox flow battery or what is redox flow abbreviation. So redox flow batteries are electrochemical energy storage devices, and redox flow stands for reduction, oxidation, and flow. So reduction, electrons are bound, oxidation, electrons are released, and it means that they can move freely, and flow, liquid stored in medium electrolyte. Energy Keeper, this project was made by international partners from 10 countries, including 2 partners from Lithuania. One is our institute. It was coordinator, and another Litgrid transmission system operator. Actually, we started this project from technology readiness level 3, and our purpose was to reach the 7th technology readiness level. And our motto was keep the energy at the right place. Yes, our project was under research and innovation action. It already is finished, and it took 3 years. Budget was 4 million euros, and as I mentioned before, it was funded by European Commission. And during the period of the project, we moved through 5 technology readiness levels: experimental proof of concept, technology validation in labs, technology validation relevant environment, technology demonstrated in relevant environment, and system prototype demonstration. And of course, under post-period of the project, our expectations entering this product to the market. In any way, we can't escape from the chemical part, even if it is not very interesting and very easy, but maybe somehow I will try to explain you how this battery works. Under electrochemical storage covers conventional batteries and flow batteries. Conventional batteries, all of you, I think that you know very well, and the most popular is lithium-ions battery. Another part is flow batteries, which is redox flow batteries and hybrid flow batteries. So redox flow batteries are divided into main types, so vanadium-based and organic-based. Ecologically friendly for environment is our case in project Energy Keeper. Talking about the concept of our project, it covers the technology object and physical body implementation and development. In our project, it was the development and implementation of battery with power of 100 kilowatts and with capacity of 350 kilowatt hours. The main task was how this battery to integrate into the smart grid. Actually, the development period of this technology had another aim, integration of renewable energy sources, electrical vehicles, chargers, and variable power consumption. And we had a demonstration in Agri's test site. It is at the Wageningen University, Netherlands. Also, Energy Keeper will develop several prosumer business models orientated to different types of communities in order to demonstrate that energy storage system will bring economic profit to end users. As I mentioned before, we made a prototype of this battery. It looks like a container. It was brought to Agri's test site, Netherlands. And yes, you can see that it is two containers, electrolyte tank energy for energy storage and cell stacks energy conversion. This is how the one and another container looks from inside. One is IT part for management, and another is chemical part, so a little bit is visible somewhere here. Let me present the cartoon image of this testing, how it looks like. In the center, you can see local smart grid controller, and it is connected with various loads. It's wind plants, green houses, and having on the roof the solar panels, and also electrical vehicle charging stations, and combined heat power plants, which uses fuel of gas. And somewhere here you see a connection point of smart grid to large power system. By this point, it could be connected to the network or disconnected. If disconnected, it is possibility to work in island mode, island regime. Also, important to mention that battery functionalities and controllability was tested. Battery interoperability and smart grid was proved during this testing period. Yes, we should discuss what was the advantages of redox flow battery. So the main four things was simple and safe. It means not flammable, not expensive, turnkey energy storage system, and low maintenance, and operatable off-grid, as I mentioned before. And also it's very clean, it's environment friendly, it's metal-free, it's saline solution as electrolyte, no aggressive acids, resource efficient and recyclable. And another point is scalable. It means that you can easily change the size of the battery. External energy storage and the power can vary from 100 kilowatts to 2 megawatts. But we started with 100 when we made testing in Agri's test site, but actually it depends on client's need. And capacity also can vary from 400 kilowatt hours to 10 megawatt hours. And also it's very important to mention that this battery is economical. Low-cost resources, feedstocks, producible in Europe. It means that no materials or any parts of equipment brought from Asia. No risk of supply shortage. High planning security and, in my opinion, long service life. It's more than 10,000 cycles possible to do. Maybe I mentioned something a little bit of this before, but I can repeat a little bit. Here in this slide you can see all consortium what companies are involved in here. 2 Lithuanian companies, as I mentioned. Our partners from Germany, Spain, Israel, Netherlands. And in this project was very good purpose reached. It was synergy between science, because Lithuanian Energy Institute is a research center, and between business. And actually, our project during all the development and implementation period was very strictly controlled by project officer. And he was supervising time by time us. And actually, we think that project was successfully implemented and be estimated as outstanding project. Also, our project was pretended to get an award. Project officer recommended to apply a proposal for EUSEF award. What is EUSEF? It's European Commission. Yes, the biggest annual event dedicated to renewables and efficient energy use in Europe. And here you can see some members of our consortium. Let's get back to the chemical part of this project. It's not very detailed, but I will try somehow to show in the simple way, because my research area also is not the chemistry. So, as in conventional batteries, negative and positive charges are done in electrode. So redox flow batteries, they are made in electrolytes. So following from this, in a catalyte tank and analyte tank. And tanks hold and saline solution. And charging and discharging is achieved by pumping the saline solution through a cell. Through this process, electrons are bound and released, electricity stored. And what the expected result? Battery's power and capacity can be scaled independently of one another. The amount of electrolyte determines the capacity of flow battery, while the surface area and number of the cells determine its power. Very similar slide will be next, but I am not going to detail it because just for review, it's a little bit more detail, and it's natural that when you meet chemical things, you need to work a lot of. It's quite complicated. A lot of testing should be done, and you meet a lot of challenges. Challenges like to, in our project, we needed to prevent capacity decay, gas emissions, over temperatures, and viscosity of electrolyte. But at the end, we solved all the challenges and moved successfully somehow. Here I would like to show our batteries context and other batteries context. Most of companies are currently focused on lithium-ion technologies and electric mobility. Yes, at the moment it's the most popular maybe batteries, but redox flow batteries are flexible, stationary alternative to lithium-ion batteries, durable and easily scaled up to megawatt storage, as I mentioned before. Also, you can see here the pairings. Actually, I'm not going through all this, but the metal-free, low-maintenance redox flow battery is perfect for applications with high technical safety requirements. Here you see the hierarchy of smart grid, which consists of high voltage grid, medium voltage grid, and low voltage grid. Actually, SCADA, where is in high voltage grid, it controls distribution management system, and distribution management system has relation with the grid control hubs of several, and the grid control hub is connected with central grid control system. This grid control, central grid control system, it controls redox flow batteries, and controlling them, they covers the needs of medium voltage grid or high voltage grid. Okay, and flexibility of storage gives opportunity for battery to participate in demand response business. In this case, in battery case, it will be battery management of battery charging and discharging. And for example, network operator, he requests 1,500 kilowatts in minus. So aggregator of residents activates community 1 and community 2 and changes the loads or generation and collects them, and later with the necessary quantity it responds to network operator. Actually, our institute was a lot of focusing on the creation of business models, and there are at least two families classes of business models. So demand response and other ancillary services. So demand response could be a change of load or a change of generation, or also in better case it could be charging or discharging. And the main buyer of these services is network operator, and provider of such a services is prosumer. In energy sale it's a little bit different. The main buyer is market, in other words supplier. Both these are built upon plus minus kilowatt or kilowatt hours are derived from load changes, generation, and storage charging, discharging. Also, what is good for aggregator, that it could be integrated in virtual power plant. And what is, first of all, what I'm talking about? What is virtual power plant? Virtual power plant brings together energy and flexibility, resources of its members, and sells it on the market. And a virtual power plant is a great option for communities. So you see on this picture a lot of collective storage communities, and each of it has redox flow battery, energy storage battery. And on another side, you see another players of market, which could be offshore wind parks, factories, shopping centers, hotels, logistics centers, etc. Virtual power plant is a group of distributed energy resources which combine to function as a dispatchable unit. And what is important to mention, that virtual power plant can be used for the purpose of participating in the electricity market or aggregating ancillary services. Until now, I actually talked about future perspectives, about the project which is not already pushed to the market, which is going to be entered to the market in the end of this year or maybe in the beginning of next year. Now I would like very shortly to review the present situation in Lithuania related with energy storage systems. I should say that a big promoter of such as technologies is our transmission system operator, Litgrid, because he has already promoted, implemented or developed, how to say, already two projects. One of it is quite small, 1 megawatt, and it was installed in Vilnius switchyard, and it was coupling with Kaunas hydropower unit. What results were reached? A battery energy system with corrected parameters can compensate for asymmetries in the power curve of a hydropower unit. And before coupling, such two physically distant units can provide frequency container reserve services, and you can see the diagram below. Another project related with the Litgrid is huge. Is maybe the biggest in Europe, not maybe, but yes, it is. It's a project of 200 power, 200 megawatts. Actually, it's total power. It's divided in 4 different places. One battery is installed at the same place as previous battery in Vilnius Vechyard. Another will be actually maybe not correct to say installed. It's on processor. Yeah, another should be installed in Šiauliai, Alytus district, and the last one in Utena. This battery will restore the system in emergency situation and resume energy supply through Lithuania in seconds, and will contribute to the rapid integration of growing renewable energy sources by storing solar and wind power and returning it to the grid if needed. As you see, the project is huge, and the budget of it actually is also very big, 109 million euros. It was funded by European Commission and project implemented by Energy Cells, which is the part of state-owned EPSO-G group. And actually, I would like to come to the conclusions that, in my opinion, our project Energy Keeper was implemented quite successfully, because we moved through the 5 TRLs, and actually we are nearly post a project period in entering this project in the market, reaching 9 TRL almost. And also we think that this battery is quite competitive with lithium-ion batteries. And what will be clients for our batteries, so network operators, as well as the demand responsible batteries, who are wind power plants, solar plants, big industrial consumers, energy communities, and ESCOs, energy service companies, in other words. And we created this battery, which should be saving your money, which should be ecological friendly for environment. And I am coming back to our motto that keep the energy at the right place. So we really hope that our battery is that place where the energy should be, keep it correctly. Thank you for your attention.
Thank you, Neringa. Anyone? Thank you. Okay, we have one question.
Maybe a short question. Thank you very much. I'm not a redox flow battery expert, but I believe there are a couple of companies already on the market, like Siemens, Schmid, and I think they are using vanadium, if I'm not mistaken. Yes, so this what I wanted to ask. What is the chemistry behind it? Maybe you showed it, but I didn't see it. It's based on which?
say how to that in English word? Druska. Yes, sail line solution. Sorry. Yes. Yeah.
Anyone else? Okay, thank you, Neringa. So the last but not least, Julius Denafas will give us the presentation about SoliTek R&D, from SoliTek R&D, sorry, about solar technologies of tomorrow. So what are you researching? Can you tell us?
I will try. Okay, so thanks for your patience, and I'm happy to make a closing presentation of our conference. So yeah, as you heard in the beginning of this conference, SoliTek R&D is part of the SoliTek family, and we started as a solar cell production team, but now we do more things and we focus more on the research. Not the laboratory level research, but more industrial level research. So that's what I want to talk a little bit about today. Yeah, so outline of my presentation will be to talk a bit about activities. Majority of our activities are based and actually partially funded by European projects. I will talk a little bit about maybe most interesting results which we have up to date. So I will talk about module performance, recycling, reliability result, and because we have nicely presented the new product, the battery, the SoliTek battery, so we also have an R&D project going about that. So I also want to say a few words about new project for us. Yeah, so main activities of our team is, of course, to support our production team with daily technological quality issues. So we try to give our insights, maybe do additional measurements to help improve the product quality. In our R&D time, we work on the module and system level innovation. So we focus on increase of yield. We are also focusing on digital operation and maintenance and benchmarking of different module technologies. We are very active in circular economy in PV. We have already second project about that. New focus area not only for SoliTek from commercial point of view, but also for our R&D activities is storage and EV charging solutions. And yeah, one more maybe activity where we are involved with our partners and let's say friend companies. So development and performance of monitoring of new cell module technologies, including IBC, flexible and lightweight PV. At the moment, we have 5 active international projects. Some of them are very close to at the end, but some of them will continue for the next couple of years. So Super PV, Highlight, Circusol, and Greenest. So you can see the topic. I will not go into a lot of details about these projects, but basically they are about reduction of LCOE through technological innovations and operation and maintenance digitalization. We work on the novel solar cell module manufacturing processes. We work on the circular business models for PV industry, and as already mentioned, on innovations related to green energy generation, storage, and by combining that, creating solutions for e-transport. I'm also, sorry, not that, oh, this direction. I'm also happy to announce that we will have one new project which has already been granted and will start by end of this year. So we will collaborate mainly with our partners from SINTEF, Norway, and we will contribute to the development of PV thermal facet elements. So this was a long time ago that we wanted to try this area and try to make some developments, but finally we will have a chance now to do that. So this is just to give you an idea that what could you expect from us during next meetings, during next presentations to talk about as well. PV thermal means that we will include electricity and heat generation in the same panel. and they will be tested on real buildings. I have to mention PV IPSI because you already heard it 2 times from Radovan and from Zygimantas, but I would also like to mention because SoliTek is leading one of those projects, so PV IPSI for the integrated solutions. So as you already heard, this project has kicked off. Of course, the funding is not yet secured, but we are preparing for that. And our project target includes, let's say, several main goals. So we want to develop and create mass production of BIPV and infrastructure integrated PV products, so 1 gigawatt. We want to scale up mass production of IBC solar cells based on Zebra technology, so 500 megawatts. We want to develop and create mass production of unconventional odd-form modules for vehicle integrated PV, also 500 megawatts. We also have a goal to implement fully automated flexible PV manufacturing line, meeting the Industry 4.0 standards. And the last goal is to establish a sustainable infrastructure for certification and testing of integrated PV products, which is, we think that but let's say European PV producers really need that, and they are lacking these testing facilities. So basically, 4 factories for different products and 1 testing center we would like to build and run through this project. Okay, now let's go to some results and come back to our, let's say, a bit smaller activities, what we do more on a daily basis. So we started 1 project, Super PV, in 2018, and finally after a few years we have some interesting results from SoliTek module performance in various climate conditions. So basically we and our partners, we build, how to say, mirror demo sites in various climate zones, so hot and dry locations in Morocco and Tunisia, hot and wet locations in Seville, Spain, Rabat, Morocco, and cold and wet, let's say, demonstration site and climate conditions in Vilnius and Oslo. In order to compare how the panels perform in different climate conditions, we set up a similar data collection equipment in every demo site. So it includes dust sensor, pyranometers, albedometers, climate station, temperature sensors on the panel, TIGO optimizers for monitoring every panel individually, data logger, and then collection of data. In addition to that, our partners from Spain and Switzerland, they developed a digital twin model for every demo site. So here is a screenshot of Vilnius demo site just to show the main idea of it. So basically we have a 3D model of the building, of the surroundings. We have a 3D model of the demonstration site with all the panels inside. And here we have the curves. And in these curves, we have power generated, which is measured by inverter or by TIGO, for example. And we also have the simulated energy curve. And we have also climate data. So what this model is doing is takes the online climate data from the demo site. It puts that into model, and it gives the output, the predicted output. So the main idea is that if there is a big mismatch between the calculated output and the real output, then we can look directly into the problems. And since we are monitoring every panel individually, so we can even start seeing which panels are underperforming, and then we can go and take a look. So the main idea, when this tool will work nicely, will be troubleshooted fully, is to offer it as a operation and maintenance tool for the PV plant owners, and basically to speed up the process of troubleshooting and of course increase the yield. Quickly, what kind of panels we have installed. So I will focus only on SoliTek modules in this presentation, and we have monofacial, we have bifacial, we have bifacial panels with some innovations, let's say, or some improvements. So 2 improvements are coatings, so they are hydrophilic and hydrophobic. is to increase the anti-soiling properties and self-cleaning properties. Then we have a reflector. So reflector means that we have a white color printed on the rear glass between the solar cells, so based to increase the internal reflection. And one more innovation is the laminated bypass diode. So this is what we are testing in these demo sites. Now, very quickly, some short videos about every demo site, and I hope I will manage to run the video. Maybe not really. Yeah, okay, now it's running. So yeah, these are short videos, 1 minute, but I will show you several different locations. So this is Oslo, Norway. SoliTek modules, CIGS flexible modules as well installed there, and also crystalline silicon modules from Apollon Solar. So Apollon Solar is not anymore in the business, but they developed interesting, but unfortunately not the successful from commercial point of view technology for the solar panels. This is the solar panel which doesn't have any encapsulant inside. Yeah, so just a quick overview how the demonstration site looks. It's a rooftop installation. The panels are bifacial, and the mounting system, as you see, is elevated. It has a certain height above the roof, so it also helps with the albedo, increase of albedo effect. Yeah, we also have demo sites in desert conditions. So one of them is in Tozeur, Tunisia. Hot climate, sandy, but also interesting, I think, location. And here's how our small demo site looks. The panels are ground mounted. They have this portrait orientation, and the mounting system is also optimized for bifacial technology, so that there is minimum shading on the rear side. So there is also a room for all the inverters and data loggers computer for data collection and analysis. So basically, in every demo site we use the same type of inverters, the same optimizers as you already saw, in order to have as equal comparison as possible. One more demo site in Morocco, it was actually used not for the comparison of bifacial module technology, but testing power electronic devices, but it was just want to show that where we are testing our panels and where that we are not only in our country, in our factory, but really with the help of this project, we expanded a little bit our geography where we are doing some research. So, of course, don't evaluate these installations like from professional point of view. These are some people did it for the first time, for example, in this particular case. So it's also learning. So we are also educating people there. So, but yeah, that's part of also these research projects. We were a bit surprised that why they haven't cleaned our modules, but I hope they will do it. When we need to send them a message to say. Okay, so quickly I want to present the results just in the, let's say, measured energy yield differences and at these locations. So I take bifacial as reference, and then basically the numbers mean that we took generated kilowatt hours during that period, and we just saw which group was better or worse. So we see that clearly, just one more time confirmation that bifacial works basically in all cases better than monofacial. The highest number we saw, it's 18% difference in Tozeur in the sandy conditions. In Oslo, we have some maybe issues with the data collection, so at the moment it's still under analysis. But in Vilnius demo site, for example, we have 9% gain comparing bifacial and monofacial. So yeah, the limited diodes, no gain. Actually, this is not a big issue because the main purpose of this experiment was to test if these laminated diodes are reliable, but maybe this time I don't focus on that. And we see that reflection gives additional from 1.5 to almost 4% gain, depending on the location in energy generation. Hydrophilic coatings, they work nicely in most of the demo sites, except Vilnius. So here we saw no gain, and we are actually analyzing why. And the hydrophobic coatings, also in 2 locations, we haven't seen any gain, and we saw up to 3.5% gain in hot climate, in sandy climate. So, so this is on top of the bifacial gain plus this on top. So it means that we can, how to say, even more expand increase the performance of bifacial modules with this kind of improvements. It was not planned, but it happened in this project a little bit by accident that we tested one of the SoliTek solid bifacial module in the humidity freeze test, and we tested it for a really long time. And the outcome is quite, I think, interesting, and we can just confirm one more time that our modules are reliable. So, you know, humidity freeze is part of the standard certification procedure, and it asks to run 10 cycles. We did 500 cycles, and we lost about 2.4% in power only, with minor visual defects as well. So this is to show you that these modules can really withstand the harsh conditions a lot. One more image also to show the glass maybe disadvantages is that also the dam heat testing. So EL images before and after dam heat, and this is after 3,500 hours. Also, we saw a little bit of maybe darker areas in EL image, but no major damage. So again, very reliable modules, and standard requirement for such tests is 1,000 hours. So we pass these things easily. Yeah, the last, I'm approaching to the end of my presentation. So of course, I still want to mention the recycling. One slide about that. In a couple of projects, we have partners who help us to recycle our panels and to analyze the possibilities to recover materials. So I hope that some of these processes will be used in the future recycling factories of SoliTek as well. But the main idea, what I want to show, that technology developed by Tech, we recycled the glass backsheet module, and we were able to extract glass unbroken. We were able to extract silicon, Templar, EVA, and also ribbons. So this is based on the water jet treatment. So basically the water jet is cutting layer by layer the panel from one side, and in this way you can control which layer you want to recover. But of course it's still a lot of research is ongoing, especially on the glass module level, how to separate it, how to recycle it without maybe losing too many materials. The work is ongoing. Yeah, and then a few slides about this new battery project, which started recently, and we are actually very happy that we are able to work on it, because it's really a source of knowledge about the new technologies for storage and electric transport. We are collaborating in this project with partners SINTEF from Norway and Protec from Lithuania. And yeah, it's funded by MITA, by the Agency for Science, Innovation and Technology. And it started last year in July and will last until April 2024. Activities, so SoliTek is responsible for developing EV charging stations and new generation autonomous bus station. Protec is responsible for lightweight PV modules and folding PV power plant based on those light PV modules. And SINTEF will test these products under Nordic conditions, or these prototypes under Nordic conditions, and of course will do a very important task, so assessment of recycling of these technology. So quickly, what we mean by autonomous bus stations. So we were really thinking what to do, and Actually, we had a meeting with Vilnius City Public Transport Department, and we just scheduled. We now have a meeting in October, and they got really attracted by this idea, and they promised to give us a space, a bus station frame, so that we could play, we could integrate our products, and we could test the performance. So we should. It will be really a real prototype, not something calculated or small scale, but real functional bus station. The idea is that it will have a battery, it will have PV modules, it will have charging points for small, let's say, electric vehicles like scooters, bikes, and or mobile phones. Yeah. Also, an interesting part of activities is this so-called battery buffered mobile EV charging station, e-pit stop. We call it like this. The idea is that will be a product optimized for use in locations with a weak grid connection, or let's say where, which means that not only the grid connection is weak, but also the investment to provide enough power, let's say, to have high charging capacities is really big. And yeah, we will build two prototypes, single and three phase. The first prototype will look pretty simple. It will be a cabinet with all components inside, like batteries, inverters, charging controllers, and there will be also charging cables attached. So yeah, the phase at the moment of this project is that we are simply buying components, and most of them they were delivered. We are waiting for some small elements to be delivered, and the assembly will start still this autumn, and we hope to start testing it in the first quarter of 2023. Yeah, but the main idea that it will also use, it will be able to have a connection from the PV for the charging, and also to the grid as well. And our partner is Protech, so they are developing the flexible PV portable system. Yeah, the video works. So yeah, the main idea is that it should be also combined, if needed, with our portable or mobile EV charging station. So we will we're focusing on that. And also in this flexible system, the lightweight PV modules should be integrated. And lightweight means that they will be based on polymer lamination, so ETFE, PET with back layer. So currently development is ongoing on mini module level, and you see that there were hail tests already done, and the EL images before and after. And yeah, so currently development is ongoing, and during next year we will definitely have some larger scale prototypes, which we will integrate into the further testings. Okay, with that, yeah, I would like to thank you. That was a quick overview about our current R&D activities. Thanks a lot.
So the last presentation, the last questions, official. Okay, thank you, Julius. So now you can relax a bit. The formal part is finished. Now we will all gather in the hallway where Julius, that man over there, you can raise your hand, will wait for you, and we will have a factory tour. We'll go to have a look what Julius showed a bit on the roof, what awaits us there. And after formal part, informal part of excursions, we will have dinner again here. And after that, the bus will be waiting for us outside. You can all see the schedule. The bus will take us to jail. Don't worry, you all behaved, so you will not be imprisoned or anything. It will be a neat part there. So, so time to relax. The relaxation time is finished. So let's gather everyone in the hallway. Thank you. To all the speakers, to you who were all to the end.